at the bottom. Destroying the rainforest for economic gain is like burning a Renaissance painting to cook a meal. I just think that's brilliant. And the talk I'm going to just kind of spearhead today is about a year's worth of like 4 hour each workshops. And I've shortened it to 20 minutes. So I'm going to talk really fast. No, I'm not. I just want to share some ideas with you of what a lot of us do that rely on a lot of this open source data. So, this is another sort of a scary topic, but environmental racism is kind of it's a jumping off point to understand that there are built infrastructure issues that contribute to where people live, access they have to resources, and locked land use systems that persist from like the early 1900s. A lot of times we think, well, the redlining and all that, that was, climbing towards 100 years ago. Aren't we over that? And when you realize, and we're going to look at some of these aspects of it, that it persists in ways that are quiet and in ways not so quiet. Now, in case you're not a geospatial analyst, I'm going to teach you everything you need to know about geospatial analytics in exactly 2 slides. I just think this is hysterical. So maybe that's the first qualifier. The two types of data, raster and vector, are basically what we look at when we're doing geospatial analysis. We have like polygons and extents and things like that. And then we have raster images that come from the satellites that are like bands and, all that kind of exciting stuff. And that's where the real mathy stuff lives that I love. So this is your 101 course. And then, I I came into geography through the back door, basically. I was a healthcare analyst and I looked at data from the huge, health records and everything. And I was just curious. I was like, what am I supposed to do with this race column? I don't get it. It's a very poor biologic construct for anything. It's more of a social construct. And I wasn't being cheeky. I just was like, well, what do you want me to do with it? And I started looking at location. Where were these clinics located? Where were these patients living? What was their environment like? Are they, if they live 10 minutes from a highway and there's pollution runoff and high levels of ozone, maybe those clinics have higher rates of asthma. And I'll be darned if they didn't. I started lecturing big health systems and a lot of the medical campuses, and we were actually putting the data layer of location and these, persistent barriers over where these clinics were seeing upticks in different types of diagnoses. And it really did there was a high probability that was amazing to see. Regarding the first law is what everybody talks about. And to me, it's the like, duh. I mean, things that are closer or more similar. But then if you think about it, if you're thinking about communities or counties, right? If your school's here, your hospital's here, the people live here, and the water treatment plant is here, proximity is going to tell you a little more about, how related some things are. So now you're all honorary geospatial analysts. The second one, though, I love, and I'm going to be honest because, I wasn't trained up as a geospatial analyst. I was looking for a tool to answer very complex questions I was trying to deal with. And when I saw this, I was like, this is it. The phenomenon external to an area of interest affects what goes on inside. That's exactly what we're all looking at, right? We're looking at environmental, we're looking at, structural determinants of health that influence the social determinants of health. And who am I? Here's my pedigree, and then we'll move on quickly. I am a exercise scientist, chiropractor who did a thesis in population genetics and then became a applied analyst through executive online education at Food School of Engineering at Columbia. So, I mean, this is stuff that anybody can do. All you need to do is be curious. And I'll share on the last slide that I'm on, like not to sell you books, but the idea that somebody who knew nothing about Python 2 years ago can take it step by step and learn how to use geospatial tools. You can learn SQL, just ways to access a lot of this open source data. We talk about accessibility quite often, but we don't always say, well, okay, there it is. Now what are you going to do with it? So this is really what spatial statistics is, because you all know, I don't want to like burst any bubbles here, but the earth is not flat. And because of this, we can only, yeah, I know, he's like, what? There's only so much you could do. You have to look at different, coordinate systems. Things are influenced by the curvature of the earth and where you are on the earth. And so the data changes and the spatial, we have spatial transform analytics and all that kind of stuff that makes it really fun. And this book has a great premise. And what I loved about it is if you are a data analyst, these buckets here are topics of open source. There's significant open source data in all of these buckets. And the long path idea is, instead of accepting what we can do as a political term, whatever that might be, 4 years, 2 years, whatever your length of term is, or, a lifespan, let's not bookend this thing. Let's think the long haul, right? Don't think of the planet as only being here for our purposes, correct? So this is a great little story that he has here that really kind of shifted a little bit of my perspective, because I didn't like being the doom and gloom person that shows up and says, look at your community. It's trash. You know what I mean? We're all going to die. I want to show people that there's a way forward. And most of us in this room, if not all of us, are kind of on that path, right? Did I not do? Oh, spacebar, not touchpad. How many brains does it take to start I hit this?
Hopefully just two.
It's the touchpad. What I'm showing you here as we get it queued up, because it does work, is, in the rainforest, a lot of times we look at satellite images and we don't know exactly what we're looking at. And what I liked about this is what started my research, because I was just scanning, looking at Landsat and, even Copernicus and all the other, is it moving?
Press spacebar.
Oh.
Sorry about that.
This is worth the wait, and I'll talk really fast to make up for it. I just want you to see it in case you're at home and you're curious and you haven't seen anything like this before. What we're looking at, it's a time lapse. There it goes. And we're looking at, the Brazilian rainforest. So as it slides towards me, you're seeing what we've done to it. And it'll go back the other way too. But what you see here is everything that's lit up is something, right? It's a land use, and this is only 4 years. And just pay close attention to the upper right corner. That's the area that I'm going to be focused on as I look at and talk about what's going on. This is, this isn't someone's opinion. This isn't somebody rattling a saber and saying, gotta save the rainforest. This is like fact. Yes. Phew, sorry. This always happens. I put all these things in here knowing that it's going to be like this. Now, this is one of the tools, open access tools, Google, excuse me, Earth Engine, where you can go in, write a lot of code. Y'all with me on that? And generate, you can look across the world, but this is the same location that I talked about, right over here. And you're just really looking at the signals from the data that are saying, like, you're looking at the bands, are they on or off, basically the pixelation in the area, and you're determining that we've lost forest, red, we've gained it, green, or we haven't lost it, green. And this is like, if you think about it, anyone could just stumble upon here. I mean, if you know JavaScript, but even if you don't, there are ways to get this information with minimal coding experience. And I just did a blow up of it because I think it's pretty. I mean, it's sad but pretty, because you can see all these areas, and you can get curious about what's happening under the surface. And this is that same region, because even in Brazil, there's a very good catalog of the vegetation in the area. So we know what's going on here. And we know what's happening on these other layers. You can't read this, I get it, but you could see the pretty colors. And like the green is the Amazonian rainforest, the lungs of the planet kind of a thing. And then you see the other areas that are marked out there. And then this now is that same image, but we're looking at a satellite image. And what you're noticing here with these pretty colors, these are the indigenous populations that live here. So what you're seeing is in this area that we were talking about up here, we have a lot of people that are impacted that might not be big fans of what's going on in the rainforest. And this is all open source data from OpenStreetMap. And then what I decided to do here is just to show you a little bit of that built infrastructure. All the yellow you see are the roads that have been put in here. So as you can see, if you look in the upper, the center top, you can see all the road networks here. And you might see them here and here. And if you're like me, you're like, what's there? A Starbucks? Like what's happening? We're going to find out in a minute. Right here, these are railroads that are put in, some railways. And I just made them black and distinct so they could pop for you if you're looking at this from home. And then I dropped out all the cover underneath so you could see those are the same native populations that we were looking at. And you may be noticing, what's all that black dots and scatter that you see on here? And what this is, right here specifically, these are all land use. So what I did is I took the open source data, I color coded it for land use, look bad, commercial bad, industrial, mill bad, not bad, but like where they're being built. And I put them on the map so that you could see, like these things seem to be a little close to a lot of the native populations and not so much in the other areas. And these are just questions. I'm not here to place a value judgment. I'm just here to say, isn't that curious? And then what I did is I blew up a bit of a satellite image on the lower left in the pop out here. And what you see right here is what's going on right here. There's a red splotch that you see on the lower quadrant here of the pop out. And then if you go over to the pink, the lower left corner of the pink, the para state, you could see that. And I blew it up and it's a mine. These are all mines. They're mining all the minerals. And you don't have to know a lot to know how destructive mining can be on a community. So this is what was generating a lot of those lights that you saw on the original image that I showed you. And
so would you mind using sorry.
I am with you. I tried to describe it. I don't, do you see the pad? I don't even, it's on, I see it here. I don't see it up here. But I think you'll have the slides. They'll get the slides. So reach out to me if you need specific direction on this, because if you look at this, the pink, if you look at the light pink on the map, you'll see a long, looks like Manhattan on an angle, and you'll see just a whole bunch of black scatter around it. And that's what I've highlighted here in the left side of the picture. Who recognizes this? There you go. Same stuff, same stuff that we can learn from, right? We're looking at here, if you notice the darker areas, the darker area. Now, I don't know, if you look at it and you pinch off your carotid and get a little dizzy, you can see a Y shape here of the white. This is water, and you'll see in the hook of it is the dark. And what we're looking at here are impervious surfaces, which are always important to drop down and look at impervious surfaces when you're looking at communities and neighborhoods, because that's where you have a lot of the flooding. That's where you have, there's no carbon sequestration. There's not a lot of green space, and you don't expect it that much in DC, but they do a nice job of putting little green spaces in the nation's capital. But what I want to point you towards, if you're looking at this, if you see the right branch of the Y, okay, so there's the Y, the right branch. I wish I could show it to you at home, but I think you can see it if you've stared at it long enough. Below this river are the 7th and 8th ward, the worst performing and most highest rate of poverty wards in Washington, D.C. And so I just wanted to point you towards the imperviousness of the soil, what that means. A lot of asphalt, a lot of parking lots, a lot of buildings, and all of that. And what we're looking at here on the left, the darker, like little polka dotted stuff in the upper northwest, those are first grade areas. So back in the 1930s, there was an underwriter's manual where the government would say who could get a mortgage and who would not. And if they were going to, mortgages have not always been funded by banks, right? You were on your own kind of, if you could get a house. And then they decided, well, gosh, if we're going to have these mortgages, we want to go in and we want to be able to check our investment and see what our risk is. So they went in, they looked around, and they're like, oh, whew, a lot of immigrants here. This is not going to be top tier. They looked at Black populations. That was the lowest. And then they gave ratings. And this is what they mean by redlining, if you've heard these things, that I mentioned it in the beginning. And so when you look at these areas, you could track it over pretty much to modern day. Now, on the right, what we're looking at is restrictions, deed restrictions. So what that means is, you may have a house, but you can't deed it to a person of color. And it's a little more complicated than all that, but I wanted to show you that there's a lot of ways of looking at these areas. And I want your point of reference to be that Y that I showed you. If you're not here with us and can't see where I'm pointing, you can see that that's a big delineator towards the population. Here it is again, big and blown up for the people in the cheap seats. The yellow here is minority population. So you pick a level. Like if it's 72% more of a certain race, then it gets put over in their category. The yellow is Black, and you could kind of see that Y again, and you can see the locked-in land use, and you can see the persistent barriers that are present there. And then just to make it fun, I thought I'd look at guns. And if you look below the Y, look for the blue, look below it right here, you could see how, concentrated these things are. And you look a little more closer. This is for my purposes of showing you, but if the data supports what I'm showing you. And I did it a little, again here, blocking out the back a little bit. So when you look here, you see the scattering, and you can see on the left vertical panel some of the choices I made. And I can mix this up. I can deselect, select, I can pick different populations, I can pick different employment forecasts, and I can look around. This is in QGIS, by the way, open source data processing, free to use today. And I can get just a look over where people are living, where's this violence happening, and then I can go there and look around. What could be contributing to this? And, this was like a great find. This is the EPA, a little company called NASA down there at the bottom. And if you look, this is so deep, this catalog of the different things. I kind of overloaded it so you could be, well, that's pretty. But you're looking at so many different things. You're looking at, hot zones. If you have a lot of impervious surface, you're not cooling and you're having a hotter temperature in these areas. And this can lead to poor health outcomes. And we're looking at a lot of other things, ozone levels. Ozone is an easy measure of like pollution runoff. Like if you're near highways, if you're near anything industrial, even commercial, there's going to be higher levels of this, and the EPA monitors this, and you can track this right down to the wards, and this works in most places. And you can see all these other measures that are in the EnviroAtlas data, open source. And here I kind of made it just a little more easier to kind of look at, so you can see what's going on. But you can look at agriculture. Agriculture is really important back in the Brazilian data I was showing you, because under the current administration, Bolsonaro in Brazil, it's like they're having a swap meet in the Brazilian, Amazon forest. Like, oh, you want some agriculture? Land's being given away, and they have this really nifty policy that if you don't have any indigenous people on the land, well, you could just take it and farm it. Well, how do you think they remove the people that they do find? They are forcibly removed, they're murdered, and this is all things you can find, and it's all in the news and in the media, locally and here. And I just wanted to pop this out for you so you could see this is all the open source data that I'm talking about, where we can look in our community, we can look anywhere where we have an interest in trying to find out, well, why are these outcomes looking the way they are? So when I was going to a lot of these healthcare systems, my job was to go in and not make suggestions, just kind of shine a little light on some potential contributions to some of the outcomes they were seeing that weren't consistent across the geographic areas that they served. And I had to get one more of these in. This brings it all together. This is beautiful. I think I made this on ArcGIS online, but there's a free API. If you know how to code, you can get in and access a lot of this data. And this is poverty status. You can see the dense, if you look for your Y again, that's why I picked DC, because it's local to us sort of, and because there's this distinct thing you can look at for resources. You can see below it, that dark swath, that's where the highest poverty rates are. So you can kind of see the continuity with these wards. And the futures is plural. Like, we're as close to 2040 as we are to the Roman Empire crumbling. So, I mean, you have to think along those things. It's not just about, do the math. It's not just about, what we do now. It's what we do going forward. 2400. I said 2040. Not that close. Not that close. But I just wanted to show you, like, here we could be here. We have different futures and different scales of how we might want to address them. There's no right way to get there. There's just lots of ways, and we just need to pick one. If you see this, raise your hand. If anyone sees it, and when you see it, if you see it, raise your hand. It's my last slide of substance. Now I'm going to tell you what you're not looking at and what you are looking at. This is a cow. Does that help? Here's an ear, another ear, an eyeball. Raise your hand if you're seeing it now. Now you see the cow. Now, if somebody shows this to you in 3 years, you can't not see this cow. You just can't. So that's my goal for what we discussed and talked about today in the little bit of time we had together, is that you don't forget the cow. And I don't mean me, I mean what we looked at. And I guess, do we have time for some questions? Did I go too fast? And while we're waiting to see if there's any question, what we're looking at here is kind of where to find me. And if you're in the room, this is really the best place, because I'm a bit of a moving target lately. But there's things for everybody, like over on Substack. There's freely accessible just stories about data and geospatial and all the stuff we were talking about. There's a couple books. I'm not trying to sell you books. O'Reilly, that's their job. They get enough of my share of the royalties that they can do the job. I just like to share it with people of things that I'm doing and where you can find me. Hi.
Hi. Thanks for that presentation. It was refreshing, different than usual. So my question is, I'm also really interested in integrating different data sets and understanding what we're looking at. But I guess I haven't heard of the Enviro Atlas before. And I guess one of the things I'm used to with working with NASA data a lot is kind of understanding the provenance of some of the data sets so that we can be comfortable with the inferences that are being made. And I'm just curious if you can speak to that with, I guess one of the challenges of incorporating lots of different data sets from different users in an open source way is that there's more question marks associated with how much we can trust the data.
Yes. Well, the point here is that I'm looking specifically for my purposes, I'm looking at trends. So I'm not looking down to that last, the fifth decimal place of anything, but what I try to teach.
Zoom out kind
Yeah,
of.
but what I do is what I teach people is all of the data sets, and if they don't, you kind of want to look the other way, is they have data dictionaries. And they'll have a little JSON file or a little meta-JSON file that you click. They'll come in these huge packages. Sometimes they're in geo packages. When you download them, it'll put like a folder, most of these sites, on your computer, and you open it, and there's your shapefile, there's your GeoJSON, whatever your poison is. And usually embedded in there is like either a CSV file, an Excel file, a PDF. It's very important. My area of specialty is the census, the US Census. So speaking specifically to that, it's an open book. You have to know how to read the book, but they go through sometimes I want to use the phrase ad nauseum of how they weighted something, why they didn't weight this, why is this different than last year, why did we make the update? It's all there. And so my answer to you, full transparency. You can't weigh the errors of the world on your shoulder when you do data analysis. You just can't. And people are going to point to things and say, hey, wait a second. As long as you're transparent, people are welcome to walk the path with you, go behind you. Not only is it open source, we're also kind of open media, right? We're all on Twitter or LinkedIn or whatever our poison is. And we can, I'd love someone to step forward and say, well, Bonnie, that data you showed, not so sure. But, when you're thinking geospatial, we have choices to make. I'm working on a piece on SQL where, you can pick how your data is going to output. Is it going to be degrees? Is it going to be meters? Is it going to be feet? These are things people miss all the time. So when you see something like Hobblegobbin looking map and you're like, well, that's weird. Usually it's simple errors. It's not anyone trying to be, nefarious.
Thank you.
But you can reach out to me if you have any questions about particular data sets. If I have any familiarity, I will help lessen that curve, that steepness for you.
We have 2 questions online. So Amanda and then Tom, I've both promoted you to panelists, so you can ask your question.
Sure. Yeah,
Gonna
great.
be
Thank you
little
for that.
holograms in the room. Where do they go?
Thank
I
you
want
for
a
that lovely
hologram.
talk. That was very interesting. I'm curious because you mentioned all of those gorgeous images that you showed that you needed to know how to code in order to generate those. So I was wondering, do you have the code that you use to generate those images publicly available somewhere?
If you're talking about the Google Earth Engine, which is the red and the green, just for example, that's Google Earth Engine. And Google Earth Engine, you just go there and you request an API and they pull you in there. And if you don't know how to code, I'm paid to teach people how to code, but if you don't know how to code, you go into that catalog and they have a code snippet, a JavaScript code snippet right at the bottom. And it says go to code editor. You just make one click and it'll give you exactly what I showed you, give or take. And you can start navigating and kind of getting familiar with it that way. So those images are very available. The other, you don't need to code to use QGIS. But what's really good if you know a little bit of SQL is if you load, like if I was going to load all the parcels, for instance, in Brazil onto a map, it would just be this scatter shot of blackness. If you can write SQL, you can say, I'm going to select from this database all land use that is quarries. And now all that other stuff goes away and you can add that new layer to your map. So that's not so please do reach out. I don't say that, lightly.
Move on, but do you want to put the question in the chat and can answer one more? Okay.
So Tom,
Go
do you
for it.
want to go ahead with your question?
That's my favorite one yet, Tom. Tom, go ahead and reach out. If you can't, if you're not getting the audio or you stepped away, just reach out and I'll be happy to answer your question in a chat or, somewhere on social media land.
Okay, the next talk is by Rachel Conley. So Rachel is a research scientist at MIT in the Media Lab who works on systems integration and analysis for NASA's Science Activation Program. And Rachel's talk is called Accessible for Learners. So go ahead, Rachel.
Rachel, it looks like you have control of your presentation, so we'll leave you to it. Thank you.
Great. Can you guys hear me okay?
Yes, we can.
Awesome. Thank you. Well, I'm sorry I'm not there in person. I'm going to turn off my audio so I can't hear. But I really welcome the opportunity to present about leveraging data for educational outreach purposes. So my degree is in physics and astronomy, but my PhD is in science education. And my research focuses on instructional design with data visualization and
Hey,
particularly
Rachel.
tools in earth and space science. So I've been a high school physics teacher, a planetarium director, and I've worked with NOVA and WGBH in educational media production.
Rachel,
So
can you hear us?
people who are this sort of combination of scientists and data and learning people, we really exist and love working with NASA. So thank you again. And some of you I've gotten to work with personally. So what I really want to talk about today is how NASA science is being leveraged. The data particularly is being leveraged for engagement through the lens of accessibility. So I have sort of two pieces to this. First, I want to talk a little bit about how it's already happening within NASA science, particularly in the science activation program that I work with, so that this is sort of a making the sausage type of conversation where you can connect to people and find other projects and potential partners right here that you don't know about already. The other thing I'm going to do then is switch to some frameworks and examples of instructional design and adaptation that's happening, and some things that we currently are in the process of trying to figure out so that you can maybe attach yourself to some of these questions and problems. So we hope you find a little bit of what you're looking for here. I'm not in presenter mode. Oh, am I presenting the wrong thing? I am really sorry.
Can you ask her to turn her sound? Because I think we saw your chat.
Okay, what is it that you're seeing?
Rachel,
I'm
can
not
you hear
seeing-
us?
Yeah, I can.
Yeah, okay, so we see the slides now, but we see your entire browser, just so you know.
Oh, that's okay. Thank you. Sorry about that. Okay, moving on. So I'm going to start with the Space Act because it really sort of centers learning as an important part of the entire audience that we're trying to reach here. So the program that I work with is the Science Activation Program, and I want to start here by really centering on all of the different pieces of this program, and then we can look through the lens of how data is being used throughout this program model. So the assets themselves lead into and work with a range of providers, and I will break these into some details shortly, that then are designed and developed into a range of offerings, programs, products, with really the goal is education and engagement for lifelong learners. And I'm going to now break down into some of the individual compartment pieces of this. So the divisions themselves have obviously over 100 active missions currently that have many different data assets, and you guys have been talking about that for days. So what I do want to highlight though is that we have some really funded and supported infrastructure partners that we work with closely to sort of facilitate some of that asset design or development. And they've been really an important part of the collaborative network. And probably, I know some of you are in this room or in this meeting. So I wanted to call out some of them particularly that focus on data and data development or design. And I've highlighted them here in yellow. And the Scientific Visualization Studio at Goddard and the GLOBE program, among the others, have already been spoken about here. So these are really important partners in developing some of the assets that we use in our educational efforts. So looking at how we are able to sort of peer into the network and see how assets are getting used for educational purposes, particularly data, I wanted to just show a network graph that we developed. These are all clickable for those who have the or I should say the links are in the slides. But I want to show you one of these and how we can sort of use it. The yellow dots represent NASA asset or infrastructure partners, and the blue dots represent funded projects. And you're able to sort of start to see where, for example, highly connected assets are being connected to a lot of different learning activities and partners and who is connected to what. And you can start to see over time, this is from 2021 to 2022, how the yellow dots are moving from more the periphery to more being integrated into the projects themselves and into the whole network. So over time, we really hope to be able to find those hubs of, who's really pulling from some of the, many different missions, many different asset pools. But that's just one tool for looking at this interface between data and integration into education. The providers that we fund through this program is currently there's 51 funded teams. We reach 21 million learners in 2021 alone across the globe, and we're in all 50 states and Puerto Rico and DC. And I wanted to just point out, if you're interested, there's a link to the impact report where you can really dive into the specifics of the who and the how if you'd like. So this is really to just call that out for you if you're interested. When you look across the many different offerings that are being provided through this collective network, there's a lot of very specific targeted data, Cosmic Data Stories, My NASA Data. I know some of you here in the meeting are actually in these projects, but I wanted to sort of make you aware that there is a range of ways that data is being made accessible for learning. And these are just some of our 162, I believe, when I last counted, offerings that we have. Next, the goal of science activation is to work collaboratively so that we can really accelerate and leverage assets across each other. And we're working across different types of mechanisms, from action groups that are very targeted and specific for, is this an issue? How do we address it quickly? To more sustained communities of practice that cut across key themes that we need to sort of be always invested in. And then backbone groups that are sort of functions that everybody, the sum is better than the parts in this case. So I've highlighted again in yellow some of these groups and communities that are really focused on data, either data applications or data practice. The visualization community of practice is one that I co-lead and is a wonderful group that I think is also really represented in this meeting today. So, or this week, I should say. The action groups, I wanted to call a project out, or a couple of projects out here that I thought you might want to be aware of. One is that we present across key issues to everybody. We have monthly meetings. And I wanted to call out one particular presentation recently by someone at Goddard Space Flight Center, Heather Mortimer, who's a graphic designer in the GLOBE, with the GLOBE program. And she developed and did a beautiful a beautiful presentation about accessibility, use of color, contrast, and importantly, the 508 compliance versus web accessibility, which is guidelines and things I'm sure we're all aware of and hopefully really trying to embed in our design of these systems. But Heather developed some great slides that we record these, we save these, we archive them. If anybody here would like to have this, I'm happy to share this with you with Heather's permission, of course. But this is a link, the contrast grid, to just one of many tools that can help with picking colors and contrast and things that make ultimately your data, like the graphs that you just saw in the previous presentation, more accessible to people who might be blind or visually impaired. So just one example of many different types of tools and presentations that we benefit from within our collective. Another one is an action group that is very active right now that is really been diving deep into the question of how the challenges and opportunities between NASA Earth System Science data and place-based approaches to what communities and educators need to really sort of understand their local environment and their local climate. And it really is a great sort of way that we're tackling what we call a last mile problem, to really understand what educators and communities need the data for, and what the barriers are. And so we've been developing these personas. I have a couple here to share with you that look very specifically at, what the pain points are, what the learning needs are, what recommendations might exist. And we're really hoping to be able to bring just even understand who the right people are to bring together so that we can co-design data tools and solutions that really enable learners and communities to have like the type of learning experiences they really need for the educational goals. And we are going to be doing a workshop in the spring at the MIT Media Lab, where we're really going to be getting together and starting to hack out some sort of initial co-design of these tools. If you are interested in participating, we'd love to have you. So please just reach out and let me know. And now I promised a couple of important frameworks and examples of how we've been designing these different tools and structural experiences, particularly for learners. So the first of the two frameworks I want to sort of highlight is the framework from the National Academy of Science. They developed a framework in 2012 that was initially released, but has been slowly growing in terms of being fundamental to curriculum development and adoption in state educational standards for the past, since its release 10 years ago. And this framework for K-12 science education has 3 dimensions to it. And I really wanted to highlight that the idea here is not just that you're learning content, but it's that you are engaging in science as an active practice and an enterprise where you're building models and you're using data. And one of those practices is analyzing and interpreting data. And when you look at the next generation science standards that were developed by putting these 3 dimensions together, and you can see the link down in the lower left here if you want to go to the NGSS site. I just wanted to call out, these are just 2 examples of NGSS standards. They're called performance expectations, but you might also hear of them as standards. One from space science and one from earth science. And I just wanted to see if you could sort of, look at this and understand just how fundamental the type of data that you're talking about in this meeting is to enabling students to actually even address and deal with and grapple with these standards. So the first one is construct an explanation of the Big Bang Theory based on astronomical evidence. And the second one is analyze geoscience data and the results from global climate models to make an evidence-based forecast of the current rate of global or regional climate change. Which, by the way, these are massive and do not just get addressed by a single lesson. These are unit-based storylines that we unpack and develop into curriculum. You can click for details on either one of these. And when you do that, you will be taken to, this is the Big Bang, evidence-based Big Bang one. You can see how it even breaks down into the practices, core ideas, and cross-cutting concepts that are involved in that one standard. So to help you get to this quicker, I worked with the Einstein Fellows at NASA last year, and we developed in partnership with people at each of the divisions, we had a conversation about how these standards connect with the missions and assets and the research of what happens at NASA. So we have now a database, and I'm happy to share it with you, that connects on the back end all of the standards to all of the different types of content and topics within NASA science. So we have that if you want to just look at like which standards are most relevant to what I do or my data sets, or how can my data better enable learning opportunities that K-12 education are dealing with. So there's a link here to the website at NASA where you can find those standard alignments. The next thing is another framework called Universal Design for Learning, or UDL for short. This is a framework that it really brings accessibility beyond just 508 compliance accessibility, and really talks about how you can design to be more accessible for learning in general. And what I wanted you to see is that we're looking at multiple means of engagement opportunities, representation, action, and expression. These are all very critical sort of pieces of being fully accessible for learning. And we have found this to be very powerful for, sometimes just even digging into one of these squares or buckets can open up a whole host of design opportunities. And I want to highlight that if you want to click here, this UDL guideline framework that I'm showing you, every one of these is clickable and then goes deep into how and ways and tools to do that. So hopefully you can find inspiration here, and we have. So I'm going to show you a couple examples of what has helped us do this. First is a tool that the design of a learner or student version of a tool. And I want to call out Jack Ireland, who I know is in the meeting and probably in the room there, and was a great partner in this. It was wonderful to work with him on this. But the question was, we know that students need to see and engage in solar data and the dynamic sunspots, phenomena that happen with the sun. And the HelioViewer tool was a really amazing open source tool to do that. But when you look at the HelioViewer, you'll see that you need to select particular instruments and observatories and wavelengths and things that sort of might be a barrier for students jumping right in and just observing what phenomena they might be trying to see. So we developed a sort of student version, which is at student.helioviewer.org, that allows you to sort of, when you open it up, you can see it's much more streamlined up here in the window. And we've really decreased that sort of cognitive load and brought the phenomena forward by allowing students to sort of pick the observation they want to make. And Jack and his team developed, the sort of what that would mean to be optimized in terms of the data you'd want to see, or the data layers or sets. And so you can just pick the type of phenomena you want to see and not have to select individual data for that purpose. So now we have this sort of great tool for kids to jump in, and right away you can go and see the sun today and pop up a little Earth viewer that scales a sunspot to the Earth, which is something the students can, very relevant for the kids. But I don't want to speak for Jack, but I think it was just sort of a great way to have a conversation about what learners need and the data tools we have, and how we can sort of leverage some great existing, content already and tools. Another one I wanted to point out is a couple of educational resources. This is how sort of a resource, not a tool, but a resource for educational use can be made more accessible. This is a link to, and you can click on the link to, an educational resource that was developed at WGBH when I was working there, that took a visualization and made a descriptive video version of it, so that when you play it, you can actually, it's a great example of how you would turn a data visualization into something that, if you were blind or visually impaired, you could still understand what's happening in the data visualization through listening to the description of it. But what's really important is, if you're trying to tell learners what's happening in data, you don't want to give them an answer. You need to give them patterns or the ability to sort of still figure it out for themselves. So this is a really great example of how to describe a data visualization set so that the students can then utilize it. And there's another one here, seasonal changes in carbon dioxide. That's a three-dimensional data set that also has a descriptive video track with it. And I know some, back to the universal design for learning, some English language learners, or even, I mean, my son who's autistic, he prefers to watch things with the descriptive video turned on because he just likes to hear the additional information. So it gives people the ability to do that if they want, or you turn it off if you don't. So that is one example of sort of how you can describe a data set. The other one I want to show is when you actually have graphs and quantitative data, it's important to, and if you click on here, you can go to this resource. It's important to remember that there are some people who have, who need screen readers or are non-visual learners, and to provide a data set that is in a format that is screen reader accessible. So, and that's sort of what this is you can put this format into a screen reader and a student who's blind or visually impaired could actually still access the data and ultimately the graph in it. So I'm going to pause and say I think that that is my time. I timed myself and I hope that was 20 minutes and not too long. I'll turn the audio back on and see if anyone has any questions.
Are there any questions online? Nope. Oh, Richard, if you want to turn your mic on, you can.
I just wanted to comment that I think that it's brilliant to have these websites where you have kind of reflow the presentation. A lot of times with scientific data and scientific information, these websites, you get thrown in the deep end, and it's right there you're excluding a whole bunch of folks just because of the complexity of the presentation. But that's brilliant. I noted that down, and I want to revisit some of my websites. Thank you very much for that.
Any questions in the room?
Hi, this is Marshall Stachinsky. I'm a postdoc at JPL, and I've been working on a chapter full of resources for astrobiology education and learning about astrobiology for people who are new to the field. And I was curious if there's any sort of aggregator or way of teachers connecting to the many resources that you described. Like you said, there was like 168 different tools to use. So I would love to be able to include that in the chapter that I've been working on about resources.
Yes, thank you. Reach out, please. I will tell you that it is a work in progress. There was and are still multiple ways to get to educational resources at NASA. And right now we're thinking deeply about how to connect to the new WebMod project. They're modernizing the website. So educational resource distribution is a really big challenge, but we are working on it, and I'd love to talk to you about it.
Yeah, I'll send you an email. Thanks.
Thank you.
Okay, no more questions, but lots of kudos in the chat for you. Okay, thank you very
Is
much.
Jack there?
Is Jack here?
Is Jack there?
Jack is online.
Okay, thank you, Jack.
All right, we're ahead of schedule. So the next talk is by Mike Jeffy. Mike is the Geospatial Open Data Lead at AWS, Amazon Web Services, and he'll be talking about how increased access to open data repositories support impact programs. So Mike Jeffy, the title of the talk is The Impact of Accessibility. So take it away.
Yeah, hi everyone. Is my audio coming through? Just a confirmation.
Yeah, we can hear you.
Great, great. I'm going to use the extra time just to make sure that I have everything under control. So excellent. Well, thank you for inviting me. And I was particularly struck by that last talk by Rachel, just thinking about open data and resources in education. So hopefully some of this will resonate in that context. As mentioned, my name is Mike Jeffy. I'm a tech business manager on the open data team at AWS, where I focus on geospatial data and their communities. As part of my work, I talk to customers, including many of you here, looking to make our large archives of geospatial data publicly available on AWS. What I'm particularly drawn to with this workshop is the focus on building community through open science initiatives and best practices. And as a representative of a very large commercial organization, I think it's incumbent on us to leverage our technology and capabilities in ways that lowers the barriers to underserved research communities. By making over 100 petabytes of high value cloud optimized data available to the public, we help lower the cost of working with data through the development of new cloud native techniques, formats, and tools. With the focus of today's session on impact of data equity and access, I thought I would share an AWS perspective on open data, how different actors discover and use data sets made available through our program, and provide a few examples of where we can affect change through impact initiatives. Assuming I stay within my allotted time, I'll try to show you a quick demo using free and open tool SageMaker Studio Lab, just to show how somebody might explore applying open science-based methods using open data. I was recently preparing for another talk, and I came across these amazing illustrations by the biologist and artist Henning Falk, commissioned by the Zara developer community. This is a community that focuses on specifications and software for storing large n-dimensional type arrays. I like to think of open data cloud access programs as foundational because of the way they change our notional understanding of working with large planetary scale data sets. And there are still a lot of barriers, as mentioned, that remain to improving access to the cloud. It certainly represents a shift in how we approach data gravity opportunity. One doesn't need to look far to draw inspiration. NASA scientist Marielle Borowitz, a former policy analyst at NASA's Science Mission Directorate, now professor at Georgia Institute of Technology, references the USGS NASA Landsat program in her book, Open Science. She discusses some of the challenges that policymakers face in early commercialization efforts, such as the Land Remote Sensing Commercialization Act of 1984. Landsat imagery at one point was around $4,000 a scene. That naturally had an impact on the number of people using that data. In 2008, more than 1 million Landsat images were distributed, and as the cost went significantly down to free. And I just included a few quotes from the Earth and Space Science publication titled Open Data to Open Science. It underlies the relationship between open data policies developed and adopted by government and commercial organizations. The White House recently released the OSTP guidance. This is new guidance to ensure more equitable access to federally funded research, and they're really setting that precedent that all communities should be able to participate in the scientific discovery process. A core tenet of the open data program is that when open data is shared in the cloud, anyone can analyze it without having to download or store it themselves. This lowers the cost of new product development, reduces the time to scientific discovery, leading to faster pace of innovation. The benefits are seen on both the supply side to accelerate R&D through the release of public data, and on the demand side, where AWS customers leverage open data to create new products, services, and insights. I'm just going to let you know that I can't hear anything. I hope everything is going okay with the presentation, just to check. We're all good. Okay. So it has been widely quoted that up to 80% of a researcher's time is spent prepping or cleaning the data to prepare for further analysis. This is commonly referred to as undifferentiated heavy lifting. One of the biggest ways we can help the research community is by increasing access to analysis-ready cloud-optimized formats that can be quickly consumed in a variety of analytic environments. By removing this part of the equation, we free up time to focus on the analysis and revealing this sort of hidden insight and patterns from the data. From decades of best practices and shared experiences, we know that siloed approaches to data management just don't scale across large organizations. A common problem every organization is facing is that data continues to grow exponentially from new sensors, platforms, and systems in increasingly diverse formats with different actors and personas who require unique insights. Our mission with the Open Data Program is simple, and that is to make more data available in more accessible formats to a greater number of people. So I just want to talk briefly about what we think of success for a data set. So first, first criteria we like to sort of talk about is that the data set is treated as a product in itself. Is it from an authoritative source? Is it stable and available in predictable intervals and formats? Second, is it provided in a way that makes it suitable for everyone to use it as it is intended, or even discover new ways that it can be used perhaps unintentionally through further optimization and experimentation? And finally, is there a well-defined community of users that understands the best way to work with that data using a common set of software tools and libraries? And just to depict this graphically, and a data set is shared in its most raw form, unprocessed, maybe a small subset of users with the knowledge and capacity to work with that data will take advantage of it. But as you continue to process the data, maybe to a higher level, naturally the usage will increase over time. However, there does reach a limit in which too much processing can hinder its usability. And that's what we're really trying to identify here. Using our program, we work with data providers to identify the formats that drive the highest community usage. A large NetCDF data store, while beneficial to scientists who are looking at data fidelity and have tools to exploit that format, may find the data set to become, others may find the data set to be cumbersome for large spatiotemporal time series analysis in the cloud and pivot towards ZAR and Parquet, some of the other more high performance compute formats. So just a quick example, when the first Landsat public data store came into our program, it was made available in S3, and there was a new type of GeoTIFF that was getting developed called the Cloud Optimized GeoTIFF, or COG. COGs allow users to request subsets of the data by leveraging a client's ability to do HTTP GET range requests to ask just for the subset of the file they need. This innovation had a huge impact on the way people work with satellite imagery, since they didn't have to pull down the entire archive of data, but could just work with the subset. So just a quick graph. Prior to 2015, the standard processing time for Landsat was fairly high among users. And as the data became ported into our program around 2015, this graph came from Bollinger, from who's at DevSeed, the processing increased dramatically. And just to provide a further example, in 2020, the USGS made the entire Landsat archive cloud accessible. Suddenly, the 25,000 processing limits that were currently documented became 500,000 per day. That increases the speed in which USGS can make this data available to the world. So tools like the Registry of Open Data and the AWS Data Exchange help users discover, share, and use data that are publicly available in S3 using common AWS resources like EC2, Lambda, and over 200 fully featured services from data centers distributed around the world. The registry contains over 350 data sets. I think it was about 364 the last time I checked, with more than 1,200 usage examples, tutorials, and publications. And these can be really great resources for education and training. So the registry is open source. Anyone can use it to list new data. You don't even have to be part of our sponsorship program to list data. So I encourage everyone to visit that, and I'm happy to share a link after. Every time a publication or tutorial is discovered, in open data, we can add this to the dataset listing and amplify the open science access. I came across a publication that uses NAPE imagery in a computer vision and machine learning application. All the code was on GitHub, and I simply added a link to that as a tutorial, and now others can use this for other study areas around the world, which I find fascinating. So one of the ways a community is able to benefit from open data is through usage examples. These can be simple web tutorials or blog posts, but sort of serve as recipes for how to access data and use it in different applications. In this example, I'm returning a list of data sets that uses Amazon Athena. This is an interactive query service. It makes it easy to analyze data in S3. Athena is serverless, there's no infrastructure to manage, and you pay for the queries that you run. Now, this query is running against Daylight OpenStreetMap. That's a distribution that's produced by Meta, and it has a series of quality control checks to remove vandalism that had become rampant in the data set at the time. And it also is available in 2 Parquet formats that are optimized for usage in a service like Athena. And that allows users to query the data very rapidly, so they could perform global queries against it. In this case, this is a query against all hospital layers around the world, and pull that data down as a CSV for really pennies on the dollar. And while the OSM data is free, I think the time spent wrangling and subsetting data is often not. So we're really just trying to make the data more accessible using some of these services. So I wanted to just shift my talk to look at some of the ways that open data can have a direct impact on communities across different geographical and socioeconomic contexts. So managing water crises is one of the United Nations sustainability goals, and the decline in the available quality and quantity of fresh water is ranked as one of the top 10 most serious societal risks. Using satellite imagery available through our program, Blue Dot Observatory built a global monitoring system for all at-risk water bodies. You can go to that website and click on that and explore the data. They developed an open source algorithm that checks for newly available Sentinel-2 imagery and process the data to filter out clouds and identify water pixels. I provided some of the architecture there and the cost, but just to note that it was done at a really low cost, but to tackle a very large societal problem. Through the NASA Space Act agreement and the NASA Impact Team, our program has exposed meaningful NASA-driven research and data to the public domain. The POWER project referenced here, this is a NASA applied science program that improves the accessibility and usage of NASA Earth observation data, supporting community research in 3 focus areas: renewable energy development, building energy efficiency and sustainability, and agroclimatology applications. POWER helps communities become resilient amid observed climate variability through easy access of solar and meteorological data via a variety of access methods. And recently, through the Space Act, we were able to launch the POWER Open Data available in both NetCDF and XAR. Just this week, NASA Earth Exchange, next global daily downscale projection GDP dataset for CMIP-6 was added. This dataset from the NASA Center for Climate Simulation was created to help support community-based approaches that examine the impact of climate change to improve the public understanding of future climate patterns at different scales of analysis. Taking a more sustainable development perspective, Amazon Sustainability Data Initiative, or ASDI, which was created to help researchers and innovators across the data information, access the data information, needed to address important challenges in sustainability. By providing research credits to organizations who are enabling stakeholders through easier access to open data and compute resources, ASDI helps programs like NASA Access and Digital Earth Africa, whose mission is to enable and track changes using Earth observation data. Through the support of AWS and donor organizations, Digital Earth Africa helps governments, nonprofit organizations, and startups, research institutions improve the way they work with EO data in the cloud. And to do this, they do this by developing products like water observations from space, water observations from space, and GeoMat, a cloud-free composite of satellite data. Organizations such as Digital Earth Africa leverage their stakeholder communities within Africa and abroad to demonstrate the value of the cloud for large-scale Earth observation analysis. I wanted to just quickly pause here and kind of pivot to the next part of my talk. Everything okay on the audio side, just since I'm not listening or hearing anything? I assume all is good.
Yeah, everything's good.
Excellent. Okay, so this example is from Sentinel-1 data. This is radiometrically terrain corrected data provided from Earth, Digital Earth Africa. And so we're able to access this data set through the Registry of Open Data and use it on SageMaker Studio Lab. And SageMaker Studio Lab is a free machine learning development environment that provides for compute, storage, and security at no cost. It comes pre-configured with common ML tools, frameworks, and libraries. And I just wanted to do a quick demo for how we could take an existing notebook, load it into Studio Lab, and use Sentinel-1 data to develop a water classification algorithm for a region in West Africa. So this may open it in a different area. I'm just going to move my browser over. Hopefully that does it. Okay, great. So this is the data set listing here. There's a description, and this is the Registry of Open Data. There's a URL, I'll provide that after, so we can list licensing information, links to documentation. And here we have the tutorials, tools, and applications and such. So you'll see an Open Studio Lab button. This is any notebook that's created for use in SageMaker Studio Lab. And really all Jupyter notebooks can be ported to this environment. We can add a button that will quickly open that up in this environment. So I thought I had signed in. That was probably one thing I didn't do this morning. And I probably didn't start it up. Okay, well, I gave myself a little extra time, so it should be okay. But really, you do not need an AWS account to access SageMaker Studio Lab. You just need an email, and you have to fill out basically a request to get access to this tool. So it'd be similar to Colab. And so one of the options here when it loads up is, and it gives you access to, I think it's 6 hours of CPU and GPU, but I can come back on that. If anybody is interested in this tool, I'll provide some real stats for that. So you can clone the entire repo or copy the notebook only. I chose to clone the entire repo. I've already done this. So here I have a couple of examples here, but I'm just going to load the one that I had before. So give me a second. Sorry. Okay, yep. That's that. Now, anybody familiar with using Jupyter? There are kernels that you can set up predefined with all of the dependencies, and that can be set up here in an environment YAML. We can also just run the installs directly in the notebook. And really, I mean, this could be designed in any sort of interactive way. But effectively, what this is doing is connecting to the Digital Earth Africa platform using Stack and the Stack API, and it's requesting data using Stack parameters. This is a standards-based geospatial metadata sort of format that allows you to kind of normalize the query parameters, particularly for Earth observation data. Here we've returned 31 data sets that satisfy a query in the area of interest. We load the data using Dask. Now it's available in an array. And it's available for, we're loading packages that we're using for analysis, things like NumPy and Xarray and Matplotlib. Here we're just visualizing a time series. This is using the VV polarization for that time frame. Radar does get very complex, and I'm not attempting to explain any of that right now. However, it's a noisy data set and one that often requires a lot of processing. So we can also display it, of course, with the other polarization, VH. This is VV, this is VH, or a combination of the two. And if you'll notice in the imagery, there's actually a lot of speckle effect. So what the authors of this notebook did was they developed a speckle filter from like an open area in Stack Overflow using Python, and they applied it, the formula directly against this data repository, which is completely open. It's We sponsored the data set, but it is in the Cape Town region for Digital Earth Africa. And they've applied that filter and now displayed that here. So this is the effect of smoothing the data. This is, again, against raw data. This is not pre-rendered or anything. So if I change the parameters, I would get different values displayed. There are different histogram plots that are here that you can kind of explore later. And then, of course, the actual thing that the goal of this exercise, which was to create a water mask or a water filter. Here it's displaying with a mean value, and here it's using the standard deviation. So that's sort of the end of that demo part. But the main point I just wanted to share is that these notebooks can become sort of learning resource tools for anyone to develop, and they don't cost anything because they're not using an AWS account to access those resources. They're just going in and running them. The caveat being that this is not intended to be sort of planetary scale analysis. This is really sort of a tool for exploring your data, but it can be a really great research tool. Let me see if I can get back into my presentation because I had a few links. But I'm happy to take any questions now if anybody has any. So that sort of concludes the presentation part, but I'm happy to take any questions.
I think we have a question online from Ryan.
Sure. Should I read it, or because I kind of lost my screen
I
controls?
think Ryan should be able to speak up if he wants to.
Yeah, absolutely. Thanks, Mike. I appreciate the talk. And there's a lot of emphasis on facilitating the creation of AI and ML models. And I wonder if there's similar emphasis, maybe something in addition to SageMaker that helps make interrogation of those models or makes those models more transparent or understandable. Are there tools like that within AWS that we should be aware of?
Yeah, there are tools. I am probably not the best subject matter expert to answer that question specifically because I don't want to misrepresent the SageMaker community. But there are, and I could definitely connect with you. I would encourage you to email me, and I have my email here, and I can follow up with some of those. But we are working on like a whole education series on sort of explaining what model applies for what scenario, and because these can't just be black box sort of you get results. It should really be transparent. So many of the models are also open source. There is an AWS Labs repo that has, I think it publishes a number of these, but you might be referring to the actual algorithm itself, and so maybe we can take that question offline.
Yeah, that'd be great. Thank you.
Sure.
Okay, we have another question online from Abdu.
Yeah, quick question here. So from astrophysics, we started to move some data to the open data program. So do we get a chance to host our tutorials similar to the ones that you showed?
Oh, absolutely. And is this a telescope data or?
Yeah, this is going to be telescope data mostly, yeah.
Oh, yeah. So Joe Flasher has been leading that effort for the most part, but I've been very fascinated with the data sets that have come on. So yes, absolutely. Because the Registry of Open Data is in GitHub, you can just go to the Registry of Open Data and you can edit the registry reference in the browser here. I'll just do that later. I know this seems dangerous, but I'm not going to edit this right here, but all you really need to do is basically add a reference in the appropriate spot. We do have some information about where that might go. I would probably, if it's a tutorial, I would add it here in the tutorial section. And if it's using an AWS service, like we can add service references, and that allows it to display with the flag so that it can come up in a query. And then when you do that, it creates a pull request, and these pull requests, then we merge them in. So the recent one, I think And this is where it's completely open, like we're not sort of hiding anything or doing anything behind the scenes. The next GDP, I mean, I was going back and forth about some of this. So really, it's a highly interactive and engaging process. I will, or somebody on the team would merge that in. So we just, there are things that we just have to make sure required tags and such. That's the process. Does that answer your question?
Yeah, thank you.
Sure. And if you don't see us merge anything, please let us know. We do have an open data at AWS or Amazon.com email.
Okay, we'll do one more question online. I think Pontus has their hand up.
Yes, thank you. My name is Pontus Olofsson. I'm with Marshall Space Flight Center. So I just have a generic question about these different cloud solutions. So we have AWS, we got Google Earth Engine, Microsoft's Planetary Computer is ramping up. From your perspective, in your opinion, how should a users and stakeholders around the world, government, universities, NGOs, whatnot, think about these different solutions? Are they competitors? Are they complementing each other? Are the different tech companies talking to each other? Or I think IBM and Oracle is getting in the game as well. So what's your perspective? What kind of recommendations would you give to stakeholders and users around the world? I think people are getting increasingly confused about which one to use.
Yeah, no, I completely appreciate your question. I sort of think about these things in a different way. I think that anybody that promotes open science and open data is providing a great value to the community. I look at Planetary Computer and I see how they created a stack catalog with all these data assets. I look at Google Earth Engine and I see a lot of really great things. So I don't see the sort of competitive angle, though I do appreciate where people are coming from with that question. I simply look at sort of we're providing resources to allow others to develop tools that solve a problem. And so I think the problem in this case is limited access to open data, potentially, or access to open data, but through certain barriers. And we're just trying to remove some of those barriers and make it easier for the public to get access. I'll use the example of the GDP CMIP6 data. There was a person at Moody's who had been requesting access to the NASA downscale CMIP6 data for months. And so, of course, the data is there, but it's very difficult for the general public to get access at times. And we're simply trying to remove some of the barriers and take that data and put it into a program where everyone can sort of share it and use it. So I think that all of these cloud service providers are providing a great value to the community, and they're furthering sort of geospatial as well. There's a big summit happening in Washington, D.C. right now, the SAT summit, and I think that you'll see it sort of reflected in that community, that really it's about impacting and affecting change. So sorry for a non-answer, but I feel like that's at least my opinion of how I see this.
Yeah, thank you. I agree
Yeah.
with that. The complementary nature is important here.
Yeah. I mean, I think it also is sort of like depending on the environment that you're working in, there's naturally going to be AWS or Microsoft or Google developers. So, really it's sort of tailored to what environment people are developing and working.
We do, but maybe, are there any questions in the room?
Thank you so much. Hello. Sorry. Thank you for your presentation. During the workshop, we've talked a lot about processing big data on clouds and as a kind of reason to rely on AWS. Could you talk a little bit about how big data on the cloud and how does that reconcile the the open source conversations that we've been having, since processing big data is costly?
Yeah, so basically you're asking about how does it reconcile with the large cost associated with processing these massive planetary archives of data. Is that correct? Like how do we address that barrier? I think this could be sort of broken down into different ways. If we look at what would it cost to do this kind of processing sort of with on-premise infrastructure or using other maybe proprietary cloud solutions that don't allow you to do on-demand scaling and processing of data. You'd be looking at a significant time investment and a significant cost associated with that. So I think it has to be a reflection of what it is that you're trying to do and how do you compare the cost of what you're trying to do to that. So the example I provided, the water observations from space, no, actually, I'm sorry, the Blue Dot Observatory, they developed a cloud solution that works against open data, that looks at all of the at-risk water bodies globally. For something like the Lambda costs associated with that, I think we're close to 10 euro a month. And I mean, if you look at a problem like water scarcity, I just don't see that cost is really a main concern there. It's really, I think it's about the data. We're drowning in massive volumes of data, and we need to exploit these features and capabilities in an efficient way to find new insights. So, and I would say that there are other tools that are free, like SageMaker Studio Lab, that would allow sort of as a learning resource, anybody to kind of explore the data and use it. You may not sort of solve the sort of pressing problem because that has to be done against a very large archive, but you can explore and prototype, and then when you're ready to get to that point, deploy. And so while I do understand the cost barrier, I think that it sort of depends on like what problem it is that you're trying to tackle, because I feel like the problems tend to cost more than the solutions. I hope that sort of addresses it.
Thanks, Mike. We probably have time for one more question. Is there a question in the room? Otherwise, there's a question online. Okay, Ryan, Scott, if you want to ask a question, you can. Otherwise, let us know and we can move on.
Sure. It was about the czar. You made an interesting point, and you mentioned czar in one of your earlier slides. And I apologize, I'm not as familiar with your domain in geospatialness, but it's interesting because bioscience is open science for bioimaging, micro CT, microscopy, even MRI are beginning to adopt that. A couple notable, like Open Microscopy Environment and European Bioinformatics are beginning to adopt this. And so it was just striking. It's a little bit of a random question, but it's cool to see a little technology information transfer across domains. So.
Oh yeah, absolutely. And the experts are probably in this room, like Shell and others who've been working with this format. I know that the migration, it's not my domain area. I know it's more the sort of the weather and side. However, it's fascinating to watch that community grow, particularly in Pangeo world. SAR just allows for that more efficient chunking and processing of the data. And I've also seen, I think there's a talk later on a hybrid approach that sort of uses NetCDF and ZAR access patterns in something called Kerchunk. So hopefully all of these things will start to come together, and it's fascinating to watch.
All right, thank you, Mike. Let's give Mike a round of applause. Okay, the next and final speaker for this session is Dr. Yaitza Luna Cruz, who is a program scientist for NASA's Transform to Open Science program and is with the Chief Science Data Office. And Yaitza's talk is entitled Open Science, an Opportunity for Equitable, Accessible, and Just Climate and Environmental Science.
Oops. Thank you, Megan. And thank you, Bonnie, Rachel, and Mike, for a perfect introduction to my talk. What a better way to wrap up this morning's session than connecting the dots with the why and talking about open science and open science as an opportunity for equitable, accessible, and just climate and environmental science. Okay, next. At its core, open science principles embrace transparency, collaboration, and participation. A commitment to open science can only be realized with an equally strong commitment towards diversity, equity, inclusion, and accessibility. Promoting diversity, equity, inclusion, and accessibility is not only fair, it improves the quality of science. I always say that collective intelligence drives the most effective solutions. We need diversity of thinking. Open science will broaden participation by historically unrepresented communities, increase accessibility of knowledge, and help communities embrace new technologies. In other words, open science is indeed an opportunity for equitable, accessible, and just climate and environmental science. As NASA Administrator Bill Nelson said, even as we fly to other planets and search for signs of life elsewhere, we must commit ourselves to build a better world here on Earth, one with equal opportunity for all. NASA's commitment to equity is aligned with 11 White House executive orders and directives from the big office. As Katie and Cerise mentioned during the first day, it is one of the priorities for the current administration. To mention just a few, we have the advancing racial equity and support for underserved communities through federal government, and also tackling the climate crisis. NASA is making immediate steps to improve its diversity, equity, inclusion, and accessibility, and early this year released the NASA Equity Action Plan called Mission Equity. This plan includes 4 focus areas: equity in procurements and contracts, equity in grants and cooperative agreements, equity in climate data, accessibility and environmental justice, and equity in civil rights, compliance, and accessibility of limited English populations. The Open Source Science Initiative is embedded in 2 of the focus areas, and I encourage you to access the QR code to learn more about the Equity Action Plan. Focus Area 3, Equity in Climate Data, Accessibility, and Environmental Justice, aims to leverage earth science and socioeconomic data sets to help mitigate environmental challenges in underserved communities. How? By making selections for new grants to advance equity and environmental justice, by making data on the cloud and converting many data sets to widely accessible formats for easier use, and by providing free multilingual training and on how to use NASA data and address priority needs in underserved communities. And I'm happy to report that we are making a lot of progress in this endeavor. And yesterday, we conducted the first ever NASA Equity Action Plan Stakeholders Town Hall, in which we reported what's going on in each of the focus areas. For example, related to Focus Area 3, this year, we selected 39 equity and environmental justice grants, and 10 of them have open science components. These projects cover topics like agriculture, energy, extreme heat, flooding, and many others climate and environmental issues that covers different issues that for vulnerable communities. Also, this focus area includes the data migration to the cloud And we are happy to report that 31 of the 50 most requested environmental data sets are now in the cloud, and we are expecting to reach 50 by the end of the year. And the full, all the earth science data is expected to be in the cloud by 2025. This cloud migration is enabling other projects like the new Visualization, Exploration, Data, and Analysis, VEDA project. VEDA's dashboard recently released an environmental justice thematic area. Our first discovery is connecting disaster recovery with environmental justice, featuring Hurricane Maria in Puerto Rico and Hurricane Ida in New Orleans. We are combining analysis-ready cloud optimized data with artificial intelligence and machine learning techniques and socioeconomic data set in a storytelling style, which is interactive and has additional resources linked to it to help communities understand these issues and to be a better resource for decision makers and policymakers. We are planning to keep adding these discoveries into into the EJ dashboard, and we are also working in collaboration with the EJ projects that we selected early this year to showcase these studies in the dashboard. And last but not least, transform to open science training. As Shell explained it, as Shell explained it during the first day, we recently released a new ROSA solicitation, and it's out for, we are accepting proposals for the advance the adoption of open science through training. We are requesting proposals to develop science core training material, the implementation of open core summer schools, and the implementation of open core virtual cohorts. This solicitation is aligned with two of the focus areas from the NASA Equity Action Plan and serves as an example of having a more equitable, inclusive, and diverse language and requirements that will allow us to minimize or reduce barriers of entry, increase outreach and training to underserved communities, and to ensure fairness in the selection process with the dual anonymous peer review process. That is all that I have for now. I encourage you to read the full NASA Equity Action Plan, and most importantly, I encourage you to bring diversity, equity, inclusion, and accessibility lenses to the work that you do. As I said before, it is at the core values and principles of open science, and together we can really make an impact and a difference. Thank you for listening, and if you have any questions, let me know.
We can start with questions in the room this time. If not, are there any online? No? Okay, well, Yaitza was kind enough. Oh, no, sorry, hold on. Question in the room.
Yeah, it's a great talk. A question about the opportunity you just spoke about for the summer school and other funding, the $3 billion thing. Is it in scope or even appropriate to consider summer schools that teach data science techniques as opposed to specifically analyzing some of the NASA open data sets?
That's in the plans. The first phase is going to be summer school to teach open core, but we are asking also to develop the science core curriculum, which is more discipline specifics. And discipline specific means that it can cover data systems or data, how to do open data or other topics in addition to the SMD disciplines. So yes, it's in the plans. Right now, in the year of Open Science, 2023, we're going to start teaching at summer schools and virtual cohorts Open Core, which is the one that is in development right now. And eventually, we are encouraging the community to submit proposals for Science Core.
Okay. Thank you.
Hey, it's Marshall Stachinsky, JPL. I am a little wary of a move towards private cloud services for data storage and accessibility reasons, because accessible data is free data. And I just wanted to hear if you had anything to speak to about plans or policy for maintaining free access to data sources.
Remember that the Open Source Science Initiative have different components of it. We are changing policy, we are creating grants, that's like the funding opportunities to allow open science, and we have the core services. So we are tackling open source science with different angles, and we are considering things like that. So Open Source Science Initiative is not free. It's not free, and we are accounting for that, and that's why we have fundings to support this kind of activities and to increase opportunity of open science to the public and lower that barrier of cost for the public. And we have Katie over there.
Yeah, just I wanted to address Marshall's question specifically. That is a completely valid concern. One of the things that we've been doing as we have been moving the earth science data to the cloud and other data products to the cloud is doing cost modeling. And that cost modeling, as you know, storing data in the cloud is one cost. Having it downloaded is another cost. So we have decades, at least within earth science, and I'm sure that other communities and disciplines do as well, of metrics that are related to how commonly or how popular our data is. And when we model for cost, so let me back up a little. Just to answer your question specifically, it is our intention fully to keep data access free in perpetuity to our data. Which means that we have counted into our cost modeling historical data to model how much it's going to cost to egress data. And so that's something that we take very seriously, because I think that, Dr. Borowitz's book, Open Space, when you make access to data free and you maintain that commitment to free and open data, you expand, the community that can benefit from it. And it is fully our intention to maintain that, as long as I'm here.
If I can amplify on that a little bit as a manager of one of those data centers. So as an example, the Global Ecosystem Dynamics Initiative came out with some very popular biomass data. And that data is up in Earth Data Cloud. NASA's paying for that egress cost. We built a model that said, how much did we anticipate? We underestimated. It was actually a very simple, easy model to go back to ESDIS and say, we underestimated, we need more money in this budget. Public basically never noticed that we had to go back and do some of that. And for that HTTP access or the direct S3 access, there's no cost. If you're going to do S3, okay, yeah, you got to have something in the cloud. But for somebody with a browser, they neither know nor really need to care that we have it in an Earth Data Cloud versus we had it on premise at our data center.
There's a question online from Rachel. You can go ahead and speak, Rachel.
Yeah, I was just wondering, looking at the Veda dashboard site, who are your primary audiences for that? Is it more of a news site, students, scientists?
I think it covers all levels because it's pretty easy to digest. It can serve as an educational tool, but it also have links and resources for more advanced. People can download the data and engage with the stories. So yes, so it's multi-level. And the Veda dashboard, it was recently released, the EJ part, and we announced it yesterday at the NASA Equity Action Plan, in which all the people related to environmental justice science was attending this meeting. So the idea is to promote this. I encourage you to share this information because this is made for the community. So help us to share these tools with the community to make a bigger impact.
Okay, great. I think that's all the questions. So let's thank Yaitza. And we have a break now, but Steve, would you like to say something before the break? Okay.
Yeah, so get everyone to the break real quickly because it's been a long session. But once definitely thank you to all the speakers this morning. It was a fantastic set of talks. I had 4 things I wanted to mention. One was obviously we've all been keeping the eye on the weather in the last couple of weeks, and obviously to the people who've been impacted, definitely hopefully all of your family and other things are safe. But obviously if you need to adjust your travel plans, please certainly do so. This is also why we have the remote attendance. So if you do have to leave early to take care of anything, please do that. And and also for everyone to travel safe and be safe wherever you are at. During the meeting, because of NASA policies, certain people haven't been able to participate as fully as they would like. This is something that was not expected as of Monday, but was discovered late. And so my apologies to those who haven't been able to participate fully, and is something that we will hopefully address in the future meetings that we have. We do want to make these as inclusive as possible and making sure everyone can fully participate during the meetings as they wish to do so. Remember to fill out proposed for the Jamboards. Here's the link. You can put in topics that you'd like to discuss. If you also have software that you'd like to demonstrate, either online or here in person, please let us know and add those as options, and we'll try and find a spot for you so you can share your software during the afternoon sessions. And my one last one is my gold star for the morning goes to Bruce Wilson for being our alt pointer and adding in the text in the chat for where Bonnie was pointing. So thank you very much, everyone. And we have a 11:45, so everyone have a break, and we'll come back and talk about the breakout sessions. Thank you very much, everyone.
Okay, welcome back, everybody. So we're going to look at the breakout session 2 topics right now. And these are the ones that are up for consideration. I will say 2 of them, if you proposed, or I guess 3 of them, if you propose these, we move them into the breakout session 1, which is on tools. So these will be included in that breakout session. But right now we're talking about breakout session 2. And we had 5 slots and we had 5 sticky notes. So that's convenient. But we will, so what I'm going to do is basically ask the people who propose this to come up and give a couple minutes summary of what you're proposing. And then after that, if anybody online or in the room has had trouble accessing the Jamboard, we'll have an opportunity for any of those people to come up and propose a breakout session if they want to. And if we end up with more than 5, then we'll do a vote. So let's start by who wrote the sticky note in the upper left-hand corner? In the pink. How do I identify groups and organizations who are unaware of NASA data and ensure these data are brought to their attention and that they know how to access and use the data? Okay, I think this is someone online, so we're just elevating them to be able to speak. Amanda, go ahead.
Hi, I think that mine is actually quite similar to some of the other sticky notes I see here. But really, I think it would be useful for us to discuss how to identify groups and organizations who may not already be aware of the data available at NASA, find a way to reach out to those groups, and also ensure that we're able to educate them on how to use all the data and tools that are available at NASA.
Anybody have any questions for Amanda? Okay, otherwise we can move on to the yellow one on the top. How do we ensure OSS tools are accessible given OSS projects? are under-resourced, and accessibility is thus often cut for time. And OSS stands for Open Source Science. If that is yours in the room or online, raise your hand or put something in the chat. Okay, this is a, yeah, would anybody like to take ownership of this that did not write it? Okay, we can move on to the next one, the green one on the top. What steps can we take to recruit more diverse workforce at our data repositories? Go for it.
So, yeah, this is Alberto Comazzi at the Center for Astrophysics. We've had really a hard time recruiting people for our team, and I'm talking mostly about software engineers and data scientists from a diverse background. We are forced by our institution to recruit through USA Jobs, essentially. And we find that most of the people who actually are qualified and end up applying for the jobs come from, backgrounds that are certainly not diverse. Most of men are, young men. So there's a gender and also racial sort of bias in the application pool. And we're looking for ideas and also, communities that we can go to help us with this.
Thanks. Any questions? Otherwise, we can go to the next topic. So the one on the upper right, in the pink, what barriers exist that prevent outreach to underrepresented communities from becoming ongoing active participation? How can they be breached?
Yeah, actually, this is mine, and it came up in a context, in a European context, at a meeting that I was at last week. The problem is that and we're talking about graduate students, early career professionals, as well as experienced senior professionals. They want to get underrepresented communities involved. They have outreach activities, they schedule conferences within these underrepresented communities, but once that has happened, there is very little long-term follow-through by any of the participants, and it is not entirely clear why. There are some thoughts that it might be related to lack of trust, lack of guaranteed funding, cultural issues related to families staying together and that sort of thing. But they're having a hard time putting their finger on why. And that does not sound unfamiliar to the American context either. So I thought it might be worth perhaps exploring what we could identify and maybe thinking about how we could address those problems.
Great, thanks, Anne. Okay, we'll go to the last one on the Jamboard. Many projects are underfunded to satisfy the core scientific requirements. Archives are growing and with new data and keeping operations at the same time. They need funding specifically for outreach/education. Yep. Hold on as we elevate you to be able to speak. Okay, you should be able to speak.
Yeah, this is Xiuqing Wu. I wrote that one because when we do our reviews, we focus on the scientific returns and all the new data we need to get into the database so the community can see it. But the portion for us, we have help desk. We reply and answer all the questions. People come up to ask us through the help desk. But there's no specifically say, okay, this is the funding we want you to do for outreach and education. We do it, but when push comes to shove and lots of new science data need to be in and all those things happen, it sort of become shifted to lower priority. But we do want to make it a higher priority, but I want to hear from others, how do you balance those competing requests from different areas.
Okay, great, thank you. So we're down to 4. And I do think that some of these can be combined. The top 3, I think, could probably benefit from the same discussions. Or do you want to keep them separate? Yep.
Yeah, I was just saying, I think the green one is a specific directed topic, but I would agree that the 2 in pink would be very related if we want to have a larger discussion on that, or have 2 groups discuss it separately and then compare, kind of what they find at the end. We could go with either of those.
Do the people who propose them have any preference?
I agree. I think that they should be combined.
The person in the room sounds like she doesn't sees them as different, and the person online sees them as related.
Yeah.
So why don't we keep them as 2 separate topics with 2 separate leaders, and then we can see what the 2 topics end up, what comes out of those discussions in the report back.
Okay. And is this a new? Okay. Okay.
The person.
Okay, so we have a new topic. How can open science at NASA build public trust and confidence in science, evidence, medicine, et cetera? So was that somebody online or somebody in the room? Shell? Okay, I think we think it's Ryan Scott, so hold on, we're going to elevate you so you can speak. Okay, you should be able to speak, Ryan.
Great, thank you. Sorry, hopefully this isn't too off topic, but there was that Pew Research Center report from March, which reported on the lack of public trust in science and medicine, especially coming out of COVID. And it sort of blew my mind across demographics, from elected officials to the public to, principals at high schools. The lack in science sort of blew my mind. And so I keep coming back to this report on everything that we do. How do we build public trust in science and evidence and training and such? But maybe this is a little off topic. I realize it might be slightly off topic though. So thank you for the consideration.
No, I think there's agreement in the room that that's a good topic for this breakout session. So we have another one in the room.
Hi. Oh, yeah. So I had 2 ideas. I've just been having trouble getting on the internet, so I have mine on physical Post-its. So one concept was addressing needs of users that are not English speakers at like the enterprise level, for when different places get things that are in different languages and need to respond and interpret questions. Another concept is how can we engage more directly with communities that we're interested in working with, and have resources be accessible to people outside of physical resources, but actual human support in person. And the model I had in mind was something like a cooperative extension model that like USGS and Fish and Wildlife uses, where there's people in different places at land-grant universities that it's their job to kind of interact with people in those communities and facilitate things that they're interested in.
Okay, great, thank you. Anybody else in the room or online want to propose something? Otherwise, we can vote, I think. Who would you? Okay, so we need to add this to the voting tool, which will take a little bit. So we have a bunch of time before lunch, so we can transition to open discussion about any of the topics or the general topic from the session this morning. I know one idea that Steve mentioned was talking about existing repositories and what they do currently to be more equitable or provide more access to users. So that's one topic, but really we can talk about anything from this morning.
This one's good. Sure.
I just want to mention something as someone that comes from minority serving institutions. I'm from Puerto Rico, born and raised, education, everything. And as one of our colleagues, Yvonne, says, you can be what you cannot see. Representation matters. In order to create diversity and recruit people and be more diverse in the workforce in our communities, representation matters. So if you are in a power position to give opportunities to people and put these people working with you, that builds trust in the community, and that's how you bring more people on board. So I just want to mention that.
Say something. Thank you for that comment. I really enjoyed that. In a practical sense, I guess just thinking of hiring an intern to a DAC or, just getting people into the facility, that immediately becomes kind of a multi-week / multi-month situation that sometimes is even too short for the window of free time. So is there any kind of way to kind of have a space that's more open to have interactions with those people and like kind of onboard people a little bit more quickly and loop them in before like the time frame of the summer passes, because it didn't start, like you didn't start in like January to bring someone on in May, for example. I mean, I want to do what you said, but when you go to do it, it can be challenging with the regulations that are in place to make things happen more quickly.
We can bring up the IO tool now. Sure.
So this is Bruce Wilson from Oak Ridge. I wanted to hit on those two pink ones. And there's, I think, 3 topics that can be separate but are also interrelated. So there's one issue, which is who are the people who don't know that the data is available? And that's one issue, and that touches a spectrum of things, both for underrepresented, excluded groups and more broadly. There's the set of folks, and Megan, we had a lot of discussion around this for Planetary. How do we identify the people who know about it, but who have run into barriers? And I was particularly struck by my experience going to a carbon monitoring system and listening to, really bright people doing work and experts in their field, and the things that caused them to bounce in terms of trying to access and work with the data. And then the third topic being more specifically the trying to tackle the barriers that are more specific to those marginalized populations, people lacking the resources, for example, to get at those. So I see we have the two, and I think that's the problem, because there's a spectrum of things, and how many buckets do we want to try to divide those into?
I have a related comment in that if we have sessions that are too similar in scope, then people are going to be divided between them who would
potentially want to be talking about both of those issues. And so I think it might be better to have fewer things on those closely related topics.
Okay.
Yeah, I just wanted to comment, keep that conversation going about reaching people that don't necessarily, excuse me, have the means to be reached or to reach out themselves. And I think it's very important for people to build trust with these communities. And that requires a lot of time and a lot of commitment from leaders and political leaders, as well as scientists and just the general public. And I think that it would be a good idea to continue discussions about science, but also starting to include or inviting other stakeholders, politicians, political or activists, because in these meetings we're making a lot of decisions about how data and how policy is going to be developed, but we're only getting one side of the equation. And I think that it's important to include people in other I don't know, specialities or other fields of professional fields, as well, like I mentioned, like politicians, as well as the general public.
Yeah, and I would add to that what Bruce mentioned as well, people who have tried to access data or tried to get involved, and were stopped at some point, to try and identify those people and bring them in so we can prevent that from happening in the future. So I think I see a lot of ties between all the comments today.
We have a couple comments on the chat. I wanted to give Ryan the opportunity to come off mute if you wanted to. You should be able to now to speak on your comment on global access.
Yeah, it might be the place. This might be the type of discussion to have that here. A couple of the collaborations that we struck up in the last year or two have involved hundreds of students internationally, and there's some interesting challenges on vetting and full. I hate to say this, but sometimes it feels like education is a bad word at NASA, whereas citizen science is an acceptable term. I'm not sure why. Maybe it's about funding and such, not to be too bluntly honest about it, but just sort of thinking about international access to the data, and also security and restrictions that also, of course, ties into, because some students were apparently connected to, this isn't an official collaboration, so there's no official collaboration with NASA, but there could be in the coming months. And so it came up in terms of vetting. Anyhow, thinking about international and student access, citizen science access might be a interesting chat, but it might be a little out of scope of what we're trying to do. So thank you for your consideration.
Ryan, I was just going to mention in regards to what you're saying, something I heard just recently from the citizen science group at NASA is the idea of community science, and they're trying to practice that more when they're working with international communities, where you're actually building the community is building the research that they want to do, and the NASA folks are just helping and empowering what the community is already doing. And I thought that was a really cool way to do kind of even moving away from citizen science to a more community-based science. I thought that was kind of interesting. And Servier, which is in the Applied Sciences program, is doing a lot of that. So just wanted to bring that up because I thought it was pretty cool. Oh, I'm Cindy Hall. I'm the community coordinator for NASA's Transformed Open Science program.
I'm also seeing a couple of a little bit of dialogue happening in the chat from Rachel. I don't know if you wanted to express those outwardly. If not, you are fine. But if you want to, you can come off mute.
Sure. I made two comments about two slightly different things. First, in talking about the pink Post-its and that conversation, it sounded like we were distinguishing maybe discoverability and reaching new audiences and engaging them versus developing solutions and that with them. So I thought that might be a good way to distinguish the conversations. I'll pause there.
If you have any thoughts on that in the room, come to the mic. If not, we can move on. Oh,
I don't think that solves the problem of dividing the audience of people who want to talk about both of those issues.
My suggestion is that we make sure there's enough time for discussion of both and we time box the topics.
Such a compromise. You must work for headquarters.
all right. Anything from the room, and then we can move on to Bruce after someone from the room.
As the author of number 2, I think it's probably best to withdraw it because apparently nobody understands what I actually meant, and it does not appear to be relevant to the things that the rest of the room want to talk about.
Well, we have 9 minutes of discussion time left if you want to elaborate.
What I had in mind has nothing to do with data and nothing to do with NASA specifically. It is a broader topic and it does not seem to be the focus of the room. So I would suggest that we withdraw it and focus on the things that the room is clearly focused on.
And I think I understand it, and I don't think it should be withdrawn. I think I understand it, and I don't think it should be withdrawn. And this is Mark Parsons. I think it relates to the bounce problem that Bruce said, and it's not necessarily just about accessing the data, but an underrepresented person tries to participate in a community, feels alienated, doesn't, or feels token, or what have you, never comes back. So it's not just engagement; it's retention. And in the developing world, they talk about the issue is not so much brain drain, it's brain retention. You know, they have the brains, so I think, yeah, how do you keep people engaged is really important, and it's not just how do you get them the data, but how do you keep them in the whole activity. That's how I understand what you're saying.
Yeah, it's all well and good to go to communities and do things and try to generate excitement. But if there isn't a follow through, if there isn't engagement in the entire process of creating science and doing science, then all you've really done is entertain an audience for a few hours on an afternoon. You haven't made a difference. And so this is trying to get to the point of how do you turn that limited engagement into a long-term relationship with the organizations and the people and the creation and deeper aspects of diversity and inclusiveness beyond just here's some data, do something. Now, I'm very fond of data, really very fond of data. But that's the gist of what I was trying to get at with that.
I mean, to me, the data sticky note that's also pink seems like a very specific, or not a very specific, and just an example sort of what you've been talking about, right? Like an application of it that we could walk through and talk about more specifically as well.
And there was a comment online that they're very interested in that topic. So someone wrote that whoever was speaking, which I think was Anne.
Yeah.
Yeah.
Okay. Well, we can talk more about it over lunch too, and decide that way too. All right. We have about 5 more minutes for discussion. Does anybody have a success story that they would like to share? No? Hashima. Could you stand up at the mic, Hashima?
Not a success story, but regarding this public confidence, I just wanted to mention something which a scientist said. So this is more like a word of caution, that if the public grabs the data and does the wrong analysis, that it could have the inverse of public trust. So I just wanted to caution that.
Yeah, I think that could definitely be included in that discussion too, right? How do you avoid creating mistrust as well?
We have some online comments. Why don't we go to Amanda?
Yeah, so in terms of success story, I mean, I guess this is still early on and ongoing, so I wouldn't say it's over or assessed or completed, but I think we're on our way to it being very successful if we can continue to get funding. But this has been brought up a few times in the conference. Is GeneLab has started an initiative called GeneLab for colleges and universities, or GL4U. And what we started doing is reaching out to undergraduate students at MSIs and HBCUs, starting with a collaboration with San Jose State University, and collaborated with one of the professors there, Steve Heller, and put together this week-long boot camp. And so I actually work with their system administrator at the time and set up a system for how to teach and process omics data from spaceflight samples. And so taught the students during this week-long boot camp of what RNA sequencing is, how to do it, and then actually they had this hands-on content where they went through with me in real time, and with my collaborator Lauren, who helped design the curriculum and teach it. And we showed them how to analyze and process RNA sequence data using the GeneLab standard pipelines. And also all this content we set up at their supercomputing system at their campus and recorded the whole thing. And afterwards, we selected 6 students to come and do an internship with GeneLab. And we've kind of kept this collaboration going this year. And this time, the educator, Dr. Phil Heller, taught the content to his students in an independent study manner. And then we had some of those students to, of course, come and do an internship with us again. And we're planning to continue this moving forward. And then this past summer, rather than educating students, we actually collaborated with JPL, and we reached educators from 4 MSIs and HBCUs to actually teach the educators this content, and then also give them all of the materials to be able to teach the content that we taught them to their students at their home institutions. The idea there being that we could reach more students this way by teaching educators and then giving them access to all the resources that they need to teach it at their home institution. So that way having access to a supercomputing system is not a barrier to them. And we did this using the SMCE system at Goddard. And so right now, one of the participants from this past summer, she's at Cal State Poly University, and she's currently teaching an independent study course this semester using the content from the boot camp. And it's been going really well so far. We have pre and post boot camp surveys just showing a huge increase in the understanding of the content of the material, and also just of GeneLab and the data that's available in there and accessible to the students. So far going really well. We're actually working on a top solicitation to hopefully get more funding to continue to do this.
That's awesome. Thanks, Amanda, for sharing.
This is Xiuqing Wu from IPAC. I posted some information in the chat, and just so I was made, I can talk. So this NITAP program is led by scientists in IPAC. I'm loosely connected with it. It has been in operations for 6-7 years, and they send out proposals, and high school teachers and their students apply for the program. We have last time I heard the subscription rate is 1 to 4, and they come to IPAC personally before COVID and online during COVID period to work with scientists in different groups to do science using the archive data. And there are a couple of very successful stories. The students went back, the teachers went back, spread the word. And recently, we hired a person to, IPAC hired a person to work on the science program, and she was a high school student who attended the summer program. So we were all very excited. So that's, I would consider, it's still continue, and I posted the website if you want to see more. That's all.
Awesome. Thank you. Thank you for sharing.
The just to let everyone know, the voting form has been posted. We filled them out. If you are in the room and you can't vote and you would like to come vote, just right before we break for lunch, you can come on down and one of the three of us will vote for you. And but please go ahead, say what you're interested in, and then we'll take a look and arrange the rooms for this afternoon, and we'll have an opportunity to post where they will be at the start of the second session. And just as a reminder, we'll start the second session for those in person at 2 o'clock back in this room and we'll have an initial set of talks, so we'll have a chance, and then we'll go to the breakouts. And I see we have a couple of questions, so why don't the people who have questions come on up?
Steve, just regarding the one topic that says, how do we ensure these programs continue after the year of open science is over? Are these programs TOPS? Are these programs data repository efforts at diversity, equity, and inclusion and accessibility? I don't understand the context of these programs. That's all. I'm just asking for clarification.
We actually don't know who wrote that one, so if you did, can you come off mute, either raise your hand or come up and we will let you explain?
I guess it'll be up to the group who discusses it.
Yep. Okay. Another question from in the room, Bruce.
So, Anne, if I can do a check for understanding, because I think the last comments finally brought home maybe what the difference was that I was missing. So there was one set of questions around how do we ensure people have access to the data? But Anne, what I heard was you were asking the question, what do we need to do to make sure that people feel like they belong in our community? Am I understanding you correctly? Okay. And for those online, she said that was an aspect of what she had to say.
Thank you. Yeah, that's an aspect of it. How do you build a community that is actually diverse? What can you offer? What is needed to break down that barrier that makes someone say, well, it's a nice thought, but it's not real. If I try to commit to this, I'm going to be wasting a couple years of my life, and it's not actually going to help me. Below the career level, when you're talking about students and graduate students and even early career scientists, if there isn't the personal connection that keeps someone involved in the field, if there are barriers to things like having computing resources that, honestly, we're making some tremendous assumptions about what people have in order to be able to use these things. We sit here and pretty glibly say, this is pretty easy. You just call up the Jupyter Notebook. If you don't actually have reliable access to an internet connection and a computer with sufficient quality to display the results and do the basic math, it's enticing, but it's a bit of a tease. And it's very discouraging to find out that these things that were described to you as being, oh, you just do this, are not actually possible in your situation. And I wonder how often these things happen and kids get all excited and they go home and maybe 20 kids are excited about astronomy and doing astrophysics, but 19 of them find out that they can't even reproduce what was done that day in class because they don't have the resources at home. And then we lose them. And that continues all the way up through. And it seems like that's something, if we could give a bit of thought to it beforehand, we could address with longer term solutions or rethink the way we're presenting some of this material that is so reliant on things that we take for granted that are not necessarily as available as we might like to believe that they are. Thank you. I understand the exchange rate on gold is pretty good.
All right, I think we'll wrap up this morning's session. Just as I said, finalize your votes. If you can't vote here, come on up to us. We'll vote for you. One additional little bonus session for those who are in person. At 1:30, we will have the SDE team. Will be set up to demo the Science Discovery Engine. So if you haven't gotten a chance, do you know what room you're going to use?
The donut room.
The donut room, yes. So so it'll be over in Read 1. Please, on your way back from lunch, stop in, see them. We'd really like to get a lot of feedback and people interacting with it. So take your time to do that, and stop in and see them. We will take a look at the sessions during lunch to see what's been upvoted and how to fit in as much of these conversations as we can. And thank you, everyone, for this morning's presentation and for this morning's discussion. Right now, the SDE is not available for virtual demonstration unless you're behind the NASA paywall, NASA firewall. And so if you are a NASA employee, you can probably reach out to Kaylin. So reach out to Kaylin Bugby. And if you're not, then please wait. And hopefully in the next month or two, we will actually have some opportunities for testing before the full public release. So reach out to Kaylin if you're interested in testing it before then, because we'd love to have people from the community testing it as well. But we're not quite outside of the NASA firewalls. And Christian, do you have anything?
Yes, a couple things. When you come up in person to speak with the mics, it would be appreciative for the virtual audience if you said your name first so they know who they're listening to. Thank you for being patient, everyone, virtually.
Everyone, thank you very much. And we'll break for lunch and return at 2. We start at 2 o'clock again.
Lead. And again, I'm happy to be here. I love these data meetings. So next slide, please. So our goals for this workshop are to receive feedback from the community on the implementation of our strategy for open science, to identify tangible activities for collaboration and development, and to build networks to support our open science vision, and also to actively collaborate and help us develop that vision. So thank you. Next slide, please. So this is our agenda for our afternoon. We're going to have 5 really exciting talks. I think what's going on in this field, especially with software and the way that science is changing, is all going to be demonstrated this afternoon. And it's really changing how we're accessing data, how NASA data users are interacting with the data is really changed over the last 5 years, and it just keeps changing. And you're going to hear about some really exciting new ways that these groups are starting to look at NASA data. And next slide, please. And then we'll go into some breakout sessions. So here are our wonderful speakers. And I see UV just turned on its camera. Our first talk is going to be on Pangeo Forge with UV Panda. Next, we're going to hear from Eric with AstroCurie and MAST, and Kerchunk. I updated the slide, but I think I did it too late. So this Kerchunk talk is being given by Martin Durant, and his Twitter is Martin Durant with an underscore in between the name and at the end. And then we're going to hear on interactive notebooks from Sarah Gibson and Komodo. So these are going to be some great talks. I'm really looking forward to them. And a lot of these people I met when I first started my open science and cloud computing journey. I think UV was at one of the, and Martin, I think as well, was at one of the first Pangeo meetings I ever attended. And such a warm and welcoming environment. I really learned a lot there and met some good friends. Next slide, please. After these great talks, we're going to break out into 2 different breakout sessions. And the first one is really focused on like some demos. So you can actually start to kick the tires a little bit with these notebooks. And the second breakout is on the following topics. And archives and access, tools are accessible, diverse workforce, and building public trust and confidence. And next slide, please. Oh, no, that's it. So Yuvi, take it away.
Hey, can you hear me? Yes. Awesome. I'll introduce UV real quick. UV Panda is a Project Jupiter distinguished contributor, a member of the Pangeo Project, and co-founder of the 2I2C Open Infrastructure nonprofit. Thanks for being here, UV.
Yeah, thank you. Can people hear me okay? I'm going to assume
Yes, and we see your screen too.
awesome. Thank you. Right.
One
thank
second,
you.
Yuvi. 1 second.
Okay.
Online, we get to see UV's screen. They just have to do it in person, I think.
Yes. Okay, go ahead.
Okay, so thank you for having me here. Thank you for the introduction. So I'm UV. This is code done with Brianna, who will introduce herself later for a demo. So this is a very short talk, 10 minutes. I'm going to talk about the Pangeo Forge community as a whole and what we are trying to do. It's a very early stage community, very new, but I think it has a long and good way to go. So what is the goal of Pangeo Forge? The goal is to do for data what Conda Forge did for software packages, or Homebrew or Ubuntu, or in some ways, like things like app stores, where as a user, or in our case as the data user, you can just sort of like, okay, my focus is to get this data so I can do my science, and I don't want to deal with like the 4 million things that come before that. Right? Like we don't want, like this on the right side is the best case scenario for installing Python that you could do if package managers did not exist. And on the right side is what we mostly do. While I think in the data world, we still have like the equivalent of the right side, right? Where like there is a lot of cleaning steps, a lot of discovery steps, a lot of ways to get it into a format where you can analyze it the way you want it. And we're trying to like, move away from that to a place where as a person accessing the data, you can focus on your work and not on data cleaning. So this, like, again, I love the analogy to the Conda Forge community. It's also what inspired the name. And if you look at who's in that community, it's software developers who are like the upstream, right? Like, so people who contribute to Python, or people who contribute to AstroPy, NumPy, SciPy, everything, and downstream users who report problems with their specific machines, with their specific circumstances, as well as the people who are experts in the tools of packaging itself, right? People who are setup tools experts, people who are Conda experts, so that they can all come together and make everything work well for each other. And it sort of provides like this common watering hole for that to exist. And this is the same for the Pangeo Forge space, right? Like you have the upstream data providers like NASA, NOAA, and everyone else, as well as the actual users, right? But then we also have the people who are the experts in the tools, like people who write Kerchunk, people who write Xarray, people who write ZAR, NetCDF, showing up to be like, all right, let's make sure that ultimately the experience is great for like the downstream end users who use the product. And it's a fairly broad community. It's not really siloed, like, it's not, we really try hard to not become like a single entity organization. These are some of the people who are already involved. And there's a strong amount of experience coming from the broader Pangeo community, which we can talk about in the breakout room if you want. But again, I just want to emphasize that, it's not like just one organization trying to do this and make it happen. So I'm going to go really quick through figuring out how this works. So the idea is that we have a community contributed set of recipes, one per data set, which really identify where the data is coming from. We can apply some fixes. I'll show you an example of that later, and then determine the output format where it's going to be, right? Because different analysts, different data sets should be in different output formats for people to use them well. And then we have the concept of a bakery, which actually takes these recipes, which are just descriptions, and actually runs it, so that the output is actually usable by users. It's cloud agnostic. We already have a bakery that's funded by the National Science Foundation, but the idea is, any organization can run its own to just help be part of the project. And of course, the output goes into object storage, which currently again is funded by the National Science Foundation, but we also have them on S3, and the goal is really for it to be close to where people can bring their own compute, right? Like we store the data and people can bring their own compute close to it to do whatever it is that they need to do. Again, so now I'm going to just go through some examples of recipes. So the data can come from anywhere. This is now a data set, and this is just like a snippet from a recipe. And we are I think this is the global precipitation GPCP thing, and then just like gets everything. But we also have with Brianna, we had worked on getting CMR integration. So this is really how it looks like to add a CMR recipe. You can see there's just a short name, and we are like, okay, we want it to be ZAR, but it could be netcdf. And then we give it a short name, we provide the axes along which we want the access to be easier, which is time, and then we also provide Earth data credentials. So this is basically what someone would need to do to add any CMR data set into Pangeo Forge. And this was added basically over the course of like 1 week, primarily because we were like, we all met up and we were like, oh, this would be cool to demo at the NASA workshop, so let's make this happen. And it was also like a broad effort, right? Like everyone just pitched in with whatever it is that they, are part of. Like nobody was like, nobody went to like, someone and be like, you help us with this. It was like, we were working on it and we were like, this is cool, let's jump in on it. And then we made it happen. So anyway, once we have a recipe, they run on bakeries, which are really Apache Beam, which is a broad open source project that processes petabytes of data every day for large companies. And it works across cloud providers, and you can run it on-prem as well if you have a Kubernetes setup like the Pacific Research Platform does. So we run it on Dataflow, we run it on Apache Flink, and we added broad AWS support specifically for this workshop because I know NASA is all in on AWS at this point of time. And bakeries are federated. We currently have one that's funded by the NSF, but like people, like this is how you build a broad-based community, right? Like you have a central space where we have a lot of different expertise, and then they're just sharing the burden of running the infrastructure, but like in a unified space. So anyone can bring it in. And then again, data is output to object storage. Open Storage Network is S3 compatible, and like sponsored by the NSF. But again, we also have them on S3 and Google Cloud Storage in whatever formats. So we also have the way to like provide like feedback and fix up data. Like I have an example here, which is someone noticed that the GPCB feedstock has negative precipitation, which is not possible, right? And then we can, in the recipe, basically write a small function that is community contributed. This shows up as a pull request on GitHub by any affected user that basically says, well, if precipitation is negative, we should drop that. But then we would be able to feed this back upstream into the data provider and be like, hey, maybe you want to fix that. But we are like, the users are not reliant on upstream having to fix it to be able to, for users to be able to use it. Only one user needs to contribute a fix and everyone benefits from that. And, this is like sort of how the broader open source community works, right? Like you fix your problem, but just not for yourself, but for everyone else. And you can go to this website and then you can discover like, like the various data sets that exist. So this is one of the data sets that we migrated. It's on AWS. And you can see this is Brianna is going to demo this afterwards. This is one of the 75 top data sets that NASA is trying to migrate. And this just was done with the CMR support. And yeah, so now I'm going to hand it to Brianna, who is over there, I think in person, to do a demo.
Yes, thanks. And actually, I might have my own issue of sharing my screen right now with permissions. So 1 second, Yuvi.
While she's getting that sorted out, I wanted to say that it has been super awesome working with this broad community because everyone just sort of like jumped in to like fix things, and we were like, oh, we were running into this problem, and it turns out someone at Google had fixed it 1 week ago, and we will like be able to benefit from that feature in like a few days. And like I'm like, this is great. Like things I don't have to fix but that benefit me is awesome. And yes, I will share this slide deck shortly.
Yeah.
Okay. Good to go, Brianna?
We have a question really quick, Yuvi.
And the question is, what is your experience, compute speed when using multiple cloud?
Oh, no. Sorry. Yuvi, from the room, but we will get to questions later.
Get to that later. Okay, yeah, great.
I think I got it, yeah.
Okay, my question was, could you explain what you mean by federated in the context that you used it? Was it that the bakery is federated, and what does that mean exactly?
That's an awesome question. Brianna, are you good to go? Should I answer the question?
If you can do it briefly, and then I'll jump back in.
Yeah, the way I mean it is different organizations can bring their own billing, their own access control, and their own resources into it. But it's sort of like more commonly managed. So you don't actually have to run your own infrastructure in terms of people power. You can just contribute. Instead of having 2 people dedicated to running this infrastructure, you can contribute 20% of one person into a broader organization that does that. I'm happy to talk more about that in the breakout session. But yeah, I think it's a really important part of this ecosystem.
Great. Okay, now we can actually get to the demo, which I'll jump in really quickly. So first, Yuvi put together this chart showing data providers, data users, and tool experts. So when I originally heard Pangeo Forge, it was from the ESIP meeting, which happened 2 months ago. And I came in as a data provider, right? I work at NASA JESDISC, and I saw, oh, hey, a public tool to try to migrate data. We're trying to migrate data. Internally, we use a tool called Cumulus that is NASA specific. It leverages CMR. And when I see what these folks are doing, I want to see how we can collaborate, right, and leverage each other's knowledge to help the whole community. So we chose one of the top 75 data collections. It's GPM monthly data. It is live on the website. You can check out the information here. And now I just want to demo that, we moved over 8,000 files, a few hundred gigabytes, and now I can access via Czar Store that entire data collection. You will be able to play with this notebook yourself later on, but this is just showing we have some S3 bucket endpoint. The data is collected and chunked then via using Czars. If you've never used Xarray before, it's a very nice interface where I can actually see, what are my variables, what's some of the metadata. Okay, this variable is daily accumulated precipitation, awesome. And I can see that I have over 8,000 time steps and some lat long grid. Going forward now, let's say I want to do some basic functionalities, right? I'm switching hats. Now I'm a data user, not just a data provider. I want to be able to plot a single time step. And because the data is chunked in times, this can happen relatively quickly, right? It's just going into the Czar collection, trying to find the right time step that I specified for some variable, and we can plot it. What if I want to also plot over a temporal range, right, through time? Now, this is a lot more complicated, right, because this is going into each one of those 8,000 files and finding that lat long. Traditionally, that would have meant you downloading the hundreds of gigabytes of data and trying to execute this locally. But on the cloud and using Czar trunking, I can efficiently go into each one of those files, get the lat long that I want, and it'll produce a time series. But it is a little bit slower than doing something like just the spatial map because that's just accessing one of the files. While that's loading, we can also do more advanced data manipulations. So if I'm an end user, right, and there's our time series, by the way. So again, that took about a minute. That's pretty impressive, right? I have precipitation for 1 lat long that was pulled from 8,000 files in about a minute. More advanced things I can do, right, as an end user, maybe I want, monthly sums of rainfall over a particular year. I can execute that very quickly. That was the execution in real time, where I can see now I have a smaller array of data. I have monthly sums of my precipitation data, and then I can go along and do more advanced visualizations. So for example, making a nice GIF, right, of this monthly data set going through time. You can use more advanced mapping techniques like leaflet that I think is just prettier, but the basics are there, right? And we're hoping this is what enables our end users to be able to leverage the data also easier. So I'm glad we're going to have a breakout session because there you'll be able to try it out yourself. We have a link. You'll be able to access the hub that we're working on right now to play with the data, or we're also happy to talk to you about how to make a recipe. Like I said, the bulk of this effort was trying to integrate CMR. So now if you have the short name of data collection, you can just put in that and it'll automatically generate the recipe to move the data in an S3 bucket. Thanks.
We are going to take questions at the end during the question and answer period. So next we'll have Eric Tollerud. Eric is an astronomer at the Space Telescope Science Institute and one of the founders of the open source AstroPi project. Eric is with us online, but pre-recorded his talk due to potential internet issues. So
For those of you online, please in the chat, let me know if you can hear the presentation or not so we can restart it for you.
I'm Eric Tollerud, the project scientist of the Data Science Mission Office at the Space Telescope Science Institute. I'm also one of the coordinators of the AstroPi project, and it's wearing really both of these hats that I want to talk to you today about the combination of MAST and AstroQuery, a data provider and an open source software project that enables a lot of interesting science using that data provider. Of course, I should define those terms in my title now. If you aren't familiar with MAST, MAST is the Mikulski Archive for Space Telescopes. You can think of it as sort of a one-stop shop for data from space telescopes of all sorts. It's most well known for Hubble, Webb, in the future Broman, other sort of flagship style missions, but there are actually dozens of other data holdings that MAST has that you can explore further at your leisure if you're so interested in. So that's the data holdings, but now we have to talk about the open source software package we're discussing here. So that package is called AstroQuery. AstroQuery is a set of tools that let you access various forms of data that are online, all meant to be used by and written through Python. Now, AstroQuery is not a part of the AstroPi package, but it's what we call an AstroPi coordinated package. That means even though you don't get it when you import AstroPi, you instead import AstroQuery, and it lives in a separate GitHub repository. It's sort of part of the wider AstroPi ecosystem. Many of the same people work on developing it, and so on. And as a result, it's also an open development project where sort of all decisions are made in the open, in sort of the pull request model on the GitHub page. You can see the link here. Now, I should highlight, I am not one of the primary maintainers. I'm one of many contributors, but the primary maintainers are really the people who get the credit for the actual code here. Clara, Adam, and Brigitte, shown here, are really the people who deserve the credit for anything directly tied to AstroQuery. I'm just here talking about the connection between it and MAST. I should also highlight, before I move on, that it's not just them either. It's some 150 or so people who have contributed to AstroQuery at this point. I'm not going to list them all. Instead, I've just listed here all the people that have more than about 40 contributions. You can, of course, go to the website if you want to see the full list. So the next logical question is, how do these things work together? So to see that, we can start from the AstroQuery documentation page. That's what I'm showing you here. We can go all the way down to the M's, in the middle of this very long list of services AstroQuery offers. And then looking more closely at that, we can look deeper into this page and see that there's actually a lot of MAST-specific functionality that's offered in AstroQuery, produced in part by the MAST team. So there's basic stuff you see at the top here, downloading data, getting started. But there's also some more mission-specific things, some more detailed catalog queries, and then some very specific things like test cut, which is specific to the test mission, obviously, and also a specific cutout service, and zcut, which is similar, accessing proprietary data, that sort of thing that's a little bit more very, very concretely specific to MAST. So now let's go and look at some of these ideas in more detail so you can get a concrete sense of exactly how MAST and AstroQuery work together. So this Python, Python script that a user might be writing can start with just a very sort of basic AstroQuery usage, which is very similar to just about anything else you could possibly do in AstroQuery, where you just ask, what MAST observations are around some particular object, and it gives you back a table that you can use to sort of further refine your search. You can also do things that are much more complex. right? Like specifically ask for HST, a specific, ID number, ask only for specific target names that you understand really well because you've delved deep into MAST and understand really well what kind of data you're looking for. Moreover, these more complex uses can look much more sort of Pythonic and like the way you would want it to look if you're a common AstroPy user, right? They use SkyCoord objects, which are provided by AstroPy. They provide results in the form of an AstroPy table, which is something that other AstroPy tools will also be able to absorb and do something useful with. So this is sort of a common principle AstroQuery follows of using AstroPy machinery where it makes sense and making only its own functionality only when something doesn't exist in the AstroPy or wider Python ecosystem. Once you've decided what you actually want to access, AstroQuery also, or the MAST part of AstroQuery, I should say, also provides very natural ways to just download your data. And this is where we hit one of the other really interesting things that MAST AstroQuery does that I think other users at this meeting might be interested in. MAST AstroQuery provides functionality that lets you transparently turn your data access into a cloud-friendly data access, where if you turn this thing on and you're working inside of Amazon Web Services, it will instead look at the S3 bucket that contains the Hubble public data, and it will not go straight to MAST to download it. It will instead find that local copy that already exists inside the AWS cloud. So this is one of the critical things, is that now the user doesn't have to think about this at all. They just ask for their data and they've offloaded any understanding of where cloud or not cloud data lives to the MAST developers who work at Space Telescope. MAST AstroQuery also provides some very special purpose things, like I was mentioning before, this test cut service, which is important for accessing cutouts from the test mission. Is something that doesn't really have a lot of other analogs in AstroQuery, but it is provided by AstroQuery.mast using this sort of special functionality, get cutouts, which gives you a nice fits object that you can interact with exactly the same way you'd be used to interacting with fits objects if you're used to using AstroPy to do that. In addition to all this functionality, one of the things MAST provides is a bunch of Jupyter notebooks that can show you how to do all of this. Right, so this to me is one of the most critical elements of all of this. It means that you can combine AstroQuery with Jupyter notebooks and create reproducible Space Telescope workflows where you can actually say, here's my science, I'm going to download the data set in the middle as part of the notebook and then do more science, right? That's what we want to encourage people to do, because then they don't have to separate the download, the data access from the scientific workflow. So we provide some examples of that in this particular case, and sort of more broadly associated with the JWST mission, which of course has just launched. Now, are people actually using this? Well, this is data from the last 90 days. I'm comparing various ways users access MAST data. So on the left, it's for everything. On the right, it's for JWST. The blue is AstroQuery and Python. The yellowish is basically all browsers where somebody goes and clicks stuff on the website. Orange is other automated ways of downloading, and gray is sort of internal usage that I think for this conversation you could just ignore. And one of the key points to take away from this is that, broadly speaking, AstroQuery is about as popular as going and downloading stuff. It's a little less or a little more depending on how you count things, but it's within the same order of magnitude certainly. So users use this about as much as they do the sort of traditional click and go and do stuff. Another thing to note is that for JWST, where we put some extra effort into educating users in how to access AstroQuery, there's a lot less usage of other kind of script methodologies for accessing data than with older missions, which I think goes to show how if you show people how to do this, they'll often just follow the patterns you suggest. Along similar lines, I want to highlight something that I learned from the ESA Gaia mission. So this is not stored in MAST, to be clear, but it also provides an AstroQuery module which is almost entirely done using the table access protocol, which is sort of a VO service, which actually depends on a different Python package, but I digress. And the result here in this public slide I'm showing you here is that basically it's a similar thing to what I just told you for MAST, where about half of all like actual queries, meaning anything more complicated than just give me everything in a cone, goes through AstroQuery, and all other sources are the other half essentially. Right, so the users really do seem to want to use this way of doing things. But then finally, I want to highlight a key point to me about how AstroQuery can work well for all of us data providers. So in some sense, AstroQuery can serve as a neutral space where users can do like what this video is showing you here, where it started with downloading Gaia data, doing some scientific workflows of selecting objects, looking at some things, doing some comparisons, and then finding some interesting result, perhaps, but then saying, oh, wait, I want to overlap this with Hubble Space Telescope imaging. So I'll use AstroQuery to download the image, and bam, here I've got a Hubble Space Telescope image directly matched to Gaia, all done within one notebook using AstroQuery, using sort of similar AstroQuery idioms. So the core idea here is that AstroQuery allowed these two very different data sources, very different ways of interacting with data, to be combined together into sort of a single scientific story in a way that wouldn't be possible if you didn't provide sort of a straightforward way of doing this that looks roughly the same and lets these things talk to each other in a fairly natural way. So to sum up really quickly, MAST tries to meet users where they are, which for many Astro users means users of Python, but in an already existing community space. So then the data providers, that's one of my hats, don't have to build their own community space. They can instead depend on an existing community space, which also benefits. That's me wearing my other hat. I'd also highlight that if you build the machinery to do this, the users will come, but if you teach them how to use it, they'll do so even more. And finally, I think it's really worth thinking about tools like AstroQuery as sort of mix and match mechanisms by which by which data providers can work together without having to work together because there's a community project that's sort of the glue that's provided between them. And I have some questions here that I think we can all think about during breakout sessions. Thank you for your attention.
Thank you, Eric. And Eric will be in one of our breakout sessions.
Afternoon, everyone.
Next up is Martin Durant. And Martin is an astrophysicist who is now a data scientist and software engineer at Anaconda, working to create software tools that transform how we see and interact with data. Thanks for being here, Martin.
Thank you. I hope you can hear me. Seeing those two talks has brought home how this session is really about different pieces that fit together very nicely. I hope you'll be convinced that Ka-Chonk, which is still very new and experimental, is a valuable part of this ecosystem and has a lot of future ahead of it. So getting stuck in, we've already heard about cloud native access, and I'm going to skip over what that actually means and why it's good for the moment, although it was hinted at in the Pangeo Forge talk previously. But I will mention, and this might all be very obvious to people in the room, but perhaps not everybody. We're talking about Python as the language of science, as the language of data analysis. And this is just, this has happened. This has become the de facto truth. It's what people learn in school. It's what grad students know coming in. And yes, there are obviously still cases where you want to reach for C++ and Fortran and other tools, but Python is not going away. And in particular, the PyData ecosystem is this really nice, very open way of sharing code and building packages that work well with one another. And it has really blossomed over the last 1 or 2 decades. One of the packages that I personally maintain is FSPec, that many of you might not have heard of, but is used under the covers of many of the other packages that you will know of, like Pandas and Dask and various other things. And the reason it can do that is because, again, it makes common API protocols that other things can hook into and understand. And it takes then the burden of, in this case, abstracting different file storage systems. It takes the burden off other packages so they can get on with doing the thing that they do well. And Kachunk is a repo by itself, but the implementation of how you use it is via FSpec. So we will give the benefits of that Kachunk is going to give you, I'll show you in a moment, to the whole ecosystem. Okay, so what am I actually talking about? What is this Kachunk thing? Well, something that you need to realize is that when you are loading array-based data, particularly, or actually most large-scale data, that data is stored in various different file formats, but actually all of those file formats have in common that they have blocks of data that are basically C buffers, or perhaps Fortran buffers, but in practice C buffers that are encoded and stored in disk. So all you have is encoded blocks, which are buffers, and some metadata that describes what they are and how they relate to each other. Now here is a bunch of file formats in front of you on the screen. And all of these are of interest to Kachunk already. And for most of them, like TIFF, HDF, NetCDF, Group2, and FITS, there are already ways that Kachunk can hook into them. And the other two, ASDF and NIfTI, NIfTI being a biological format, if anybody hasn't heard of that one before.
Martin, sorry to interrupt. Can you give us a few minutes? We're having a little technical difficulty in the room. Can you pause for just a second? Thank you. Martin, if you can just hold on one more minute. We're working on it. Thank
It's
you.
all right. No rush from me.
Martin, you can continue. We apologize.
All right. Where was I? Right. So the point of this slide is that all of the file formats contain buffers, which are just encoded blocks of C memory. For the example of HDF5, which was the first format that I considered, could you see my pointer, by the way? If I wiggle it around? Maybe not. Okay, I don't think it's important. So the structure of a file is that it has these blocks of bytes, and these bytes are just, you take a C buffer in memory, you encode it, you compress it, and you put it in the file. That's how a file is created. So we could reverse this process. If we can find the byte range that corresponds to a buffer and how it was encoded, then we can reverse the process, load that data, and rebuild the array in memory just by knowing what the encoding is. And how do we find these blocks of bytes in a file? We can scan through the metadata of the file. So what Kachunk basically is a bunch of scanning functions specific to each type of file format that goes through the metadata. It extracts that metadata and the byte ranges of all of the blocks that are contained in there. And what's more, you can do this for many files. So here is an example where we have, let's say, several HDF5 files on the left. We go through them, we find all the blocks, we read all the metadata. And what we do is we create a reference set. That's what I'm calling it, in which we give each block of data a fake file name and make a file system-like object in which each of the files in this file system-like object points to one of the blocks of bytes. And we also write metadata files that tell you how to extract from these blocks of bytes into arrays. Now, this structure in the middle here with this / set of file names, this is exactly what the ZAR library needs in order to be able to read one whole array from many different blocks into memory or access part of it. So what we've done here is, without duplicating the data, without transforming the data, without re-encoding the data, we've basically made it look as if it is a ZAR dataset just by creating a relatively small mapping from blocks and byte ranges into this file system-like structure in the center. What does that all mean? Well, it means for the user that you get what I'm calling cloud-friendly access to the underlying data. That is, you get all of the good things that the CondaForge pattern gives you that was mentioned earlier in the session. You can access the different blocks in parallel with something like Dask if you wish, or any other parallel library. You can take these definitions and you can transmit them in a distributed cluster so that you can run massively parallel tasks on them. You can asynchronously fetch many blocks at once so that you get around any latency problems that is very typical for remote storage. You can make lazy data descriptors. This is very typical, again, for actually, even fits and other things do this, right? You don't have to load the whole thing into memory. You can load just the bit that you need by using normal Python selection syntax. So that's going to work. And so laziness leads to only loading what you need. And all of this is done without any service, any data duplication, no always on thing. Once you've created the references, it all just works, and it works in the usual Python framework that people are used to analyzing their data already. So this is very powerful stuff. And what's over, we can form aggregate data sets that view potentially many thousands of input data files as a single aggregate data set. So you can just select by coordinate. This is like an X-ray thing, but you could do this with other packages too. You can select by coordinate the part of the data that you need just by using like simple pandas style square bracket notation. You don't need a separate package to do the queries for you. It's all there. So in the breakout session, we could do some demonstrations of this, and we can talk about what is and isn't possible. We can go over where the project might go in the future, but there are definitely some caveats that need to be mentioned up front. First one, I'll go through all of these. If you have a FITS file with many blocks of data within it, but you've gzipped that FITS file, you're not going to be able to scan it with Kachunk. This is because gzip basically makes all of your bytes a single binary stream. And in order to be able to find any block within that stream, you have to start at the start of the stream. So that doesn't work. Now, FITS actually supports internal compression, which surprises many people, but it does. If it has that, then that is totally fine and it's going to work with Kachunk. Most other formats have internal compression, where you have the blocks of data are separate and compressed individually. And so we can grab one of those blocks of data and decompress it on load, and that all works nicely. You are limited to what chunking is in the original data. So unlike the ability of Pangeo Forge to apply rechunking on load so that you can create your data in a format that's most appropriate for the analysis pattern you expect to have, you're stuck with however those files were originally laid out. For the time being, we don't support all possible codecs that are out there, but we support them as they come in, and people say, hey, this isn't supported yet, then we can do it. There are quite a few that we already support. Some formats are harder than others. The particular bane of the ones that I've shown so far is GRIB2, which those in the meteorological community will know about, but probably nobody else. It's to do with model predictions of climate models and that kind of thing. And then the final one. So this is the most interesting one for this community. If you're using something like X-ray that already can load from this kind of data, then everything is good. If you're using AstroPy and AstroPy expects FITS or maybe ASDF, then what do? How do you integrate this thing into that? And I would suggest the most easy way is to actually make AstroPy be able to load from FITS. But there are other, from ZAR instead of only from FITS and ASDF. But there are other possibilities that we can talk about. This integration of how do you expose this cloud friendliness to existing tools is probably the hardest thing to solve. And then there's a whole bunch of things that I am personally working on with some other people to push this forward for the future. And I don't need to spend much time over going on about what's on this list. These are all good things that are going to make this even more interesting as time goes forward. I repeat that the whole Kachunk idea is pretty experimental at the moment, and this is the time that it's becoming more mainstream. And now you're actually able to scan very massive data sets and produce reference files and access them. Of note here is that you get some of the benefits of what was mentioned in PangeoForge. You can update the metadata as you do your scanning. So you don't have to change or copy your original data. You can just have updated metadata in the references that you save. This reference file is a small thing and it can be saved anywhere alongside the original data, somewhere completely different. And there's an issue here that I'm pointing people to that are going to be my short-term work tasks over the next 3 to 6 months, something like that. So stoppage aside, I think I probably got to 10 minutes there. So I just encourage people to look at the documentation and then we can talk about this later. Thank you very much.
Thank you, Martin. That was great. Next up is Sarah Gibson, and Sarah is an open source infrastructure engineer at 2i2c and mybinder.org operator. One of her specialties lies in reproducible computational environments for scientific code sharing and collaboration. Welcome, Sarah. Sarah, do you need us to share or do you want to share your screen?
I did want to share, but I've just realized that I might need to give permission to Google Chrome. So hang on a sec. No, it's saying I'm not allowed. Could you share for me, please?
Of course.
Thank you. There is the very last slide is interactive. There's a link on it, which is a link to a binder.
All right, Sarah, let us know when you can see the screen and I will change slides when you say next.
Great, I can see the screen. That's perfect. Thank you. So, hello everyone. My name's Sarah Gibson. As was mentioned, I work at 2i2c as an open source infrastructure engineer, and I also operate mybinder.org, which is a platform for sharing interactive notebooks. Next, please. So I wanted to start with this quote, which is about an article about computational science in a scientific publication is not the scholarship. It is merely advertising of the scholarship. The actual scholarship is a complete software development environment and the complete set of instructions which generated the figures. This is basically saying that PDF files and paper outputs aren't enough if we want to truly stand on the shoulders of giants and reuse work that has gone before. We need to be sharing our software development environment and our code and our data sets as well. Next, please. But doing that is really, really hard, especially if you're going to share a computational environment. You need hardware, so something to actually run code on, like a computer. You need software, including the programming language, any additional packages, and the code itself. And you need resources as well. One big one is data. And I think the last 3 talks have covered really well how we can, different ways of accessing data. And there's also the incentive structure within academic science just isn't built towards us learning how to do these things. You have to learn extra skills to be able to provide all of these things. And it takes a time investment at the beginning of your project to be able to have a shareable computational environment by the end of it. Next, please. So this is why Project Binder exists. So now we're going to go over a few, what it is and how it can help. Next, please. So Project Binder is a global community of data scientists and software engineers, and we are dedicated to shareable computational environments. Mybinder.org is a free and public service that allows anyone to launch interactive computing environments in the cloud by clicking a link in their browser. So we are taking ownership of all of that difficult stuff involving building and sharing a computational environment. But we're not doing it in a condescending way because we are open source and you can go and learn about all of the tools if that is what you need. But also you can use this service without actually knowing a lot about what's going on under the hood either. Next, please. So this is a little cartoon of how a research scientist might use mybinder.org. So we've got Jane here, and she's written a paper based on her experiments, and she wants like anyone to be able to reproduce, check, and improve her calculations. So I do a really bad thing of animating my slides by just adding new slides. So I apologize to the person clicking next, but next, please. So the first thing she does is she combines all, she describes her experiments in a Jupyter notebook, and she mixes together her prose, her code, her visualization, and she includes all of her resources, the source code, data, media, and she bundles it all together. Next, please. She then publishes them on a publicly hosted repository, such as GitHub, Bitbucket, GitLab. Other repositories are supported as well, such as Zenodo. Next, please. And then she makes that repository binder ready by describing the software required to run the notebook in a configuration file. So what's this configuration file? Well, it's nothing special, actually. You're all already familiar with these configuration files. It's your requirements.txt file. It's your environment.yaml file. It's an R namespace and description file. It's an apps.txt file. All of these are places where you list your software requirements, and that is a valid binder configuration file. And by putting all of this together, everyone can now run and reproduce her computations on the cloud. Next, thank you. Yeah, no, that was totally fine, thank you. Great. So what's going on behind the scenes of this? So here's like a little snippet of the form you see when you go to mybinder.org. You've got a place to put in your repository URL, and you click launch. And then a load of stuff starts happening in the background. First of all, your repository is cloned. We then use a tool called repo to Docker that builds out a Docker an image of your computational environment using the instructions in your repository. So that requirements.txt file, that environment.yaml file, that namespace and description file. Repo to Docker reads them, knows how to handle them, installs everything, and copies your code and any other contents of your repository along with them. What do we do then? We use Docker to execute your image. Everything is running on top of a Jupyter Hub. So Jupyter Hub allocates some computational resources to this container, and then also makes the container accessible at some URL. And then I like to think of Binder as a layer that sits across all of the top, coordinating all of these different steps, but also redirecting your user's browser to that URL. Next, please. So this is the interactive part. This is a URL. It's just disguising a mybinder.org URL, actually. But if we click on that, we'll be taken to a tutorial that came out of LIGO's first detection of a gravitational wave from two black holes merging, and they created this interactive notebook that takes you through all of the analysis. So if we click on that link.
One moment, I'm changing screens.
No problem, thank you so much. Basically what will happen is we will be put into a Binder environment, and all of the information will be there ready for us to do gravitational wave science. How exciting. So this is the Binder launching page. You can click on build logs actually to see what's going on in the background. So it's found a built image, and now it's requesting that computational resource that we asked, and it's pulling the image from a container registry. This is running on the OVH cluster. So the other cool thing about mybinder.org is, like PangeaForge, it is federated. A few people around the world run Binder hubs that are all accessible via mybinder.org, and you are dynamically directed. So this is live. Hopefully the pull won't take too long. I've also noticed as I've been like demoing this talk that OVH pulls the image every time, which some of our other clusters don't, and I'm finding that very interesting. And this will be, what will happen in a couple of seconds is we'll get launched into Jupyter Lab with our notebook. Here we go, starting container. So if you could, from the menu, click run and then run all cells, please. And that'll just make sure everything's executed.
Where is that on the screen? I apologize.
At the top underneath the LOSC event tutorial.ipynb, the top menu bar. Up. Yep. Warmer to the there we go. Run.
Okay, sorry.
And then run all cells, yeah. And then just like slowly scroll down the notebook. That'll be great. Thank you. So yeah, this is like a full tutorial on how you can do data science, and a little bit faster than that because there's some cool graphs, please. And all of these cells are interactive. None of the computation is happening locally. It's all happening in the cloud, so you don't have to worry about installing the correct libraries or anything. You get this chance to play around with all of this cool data and all these cool cool packages. And yeah, so we're coming to the first graph here, which is the strain data from the 2 LIGO arms. And they've also got some of the chirp data and the spectrographic data as well. We've gone through all of the formal part of my talk now. This is just me demonstrating a binder. So thank you very much for listening. I can post the link into the chat as well, so you can have a better look through that. That's just a thank you slide. A lot of the work I did on Binder was through the Turing Way as well, and you've probably heard of that if you're involved in NASA TOPS, and I do recommend you check out that project. So thank you very much.
Thank you, Sarah. That was great. Next up, we have Rebecca Ringett, and Rebecca is the lead software developer at Komodo, a NASA CCMC, and that stands for the Community Coordinated Modeling Center at NASA Goddard. It's a tool for functionalizing data of all sorts and has interests in science infrastructure. Thank you, Rebecca, for being here.
Rebecca, if you are speaking now, you are not off mute. Otherwise, we can troubleshoot for you.
I'm trying to find the mute button. I'm sorry.
We can
I
hear you
lost
now.
the window. That's because I'm holding the space button down. I can't do that the whole time. Hold on. Well, I guess I'll hold. Oh, got it?
Yep, we unmuted you manually, so you should be able to talk freely now.
Thank you. And now I'm sorry. I'm usually really good at this, and I just lost everything at the last second. Okay. My WebEx has disappeared. Okay, can you see my slides?
Yes, we can.
Okay,
You are
then I
not
will
in
just.
presenter mode, though.
Gotcha. Okay. I think I know what happened. So what do you see now?
We can see you in presenter mode.
Okay, let's go. All right. Hi, I'm Rebecca Ringett. I'm talking today about how we at the CCMC are using Komodo to lower the utilization barrier for heliophysics model outputs. So Komodo is split into 2 GitHub repositories. Both are open source. The QR code on the bottom left is to the Komodo core repository, which is maintained by Ensemble Government Services. And that contains all of the core capabilities of Komodo that we build upon. The QR code on the bottom right shows has the link for the NASA GitHub repository, which has all of our heliophysics specific work. So I'm showing this today as a demonstration of what could be done in other fields, particularly, well, any data types. And it's not advancing. There we go. All right, so here is listed a sample of models that we host at the CCMC. The CCMC is a trusted repository for heliophysics model codes, such as the ones displayed here, named here, and we are dedicated to making the results of these models open and accessible to the community. We host a large and growing number of models and provide access to their results through a growing number of services. These services range from user interfaces to requesting custom model runs and forecasting and validation tools. All of the tools are free and open to the community through our website, which is at the top of the slide. Today, I will be focusing on how we are using Komodo to provide a more interactive interface between the community and model results than was previously possible. First, let me answer the question, what is Komodo? Right? Okay, well, Komodo is an open source Python software package whose capabilities are built upon functions and interpolators. So once a data set is functionalized, such as you see in the first block, some interesting capabilities are automatically possible with simple commands. The second block shows example commands of how to perform unit conversions in the first line, first non-commented line, function composition with this diff line, and then how to show the LaTeX representation of all of these things so a human can read that more easily. The bottom block shows an easy way to do interpolation with a simple command once the data is functionalized. Some other interesting capabilities include very simplistic syntax to generate publication quality code, visualizations, with all of the powerful capabilities that Plotly offers. Komodo uses Plotly to power its default visualizations. The links to the GitHubs are also on the bottom left. Okay, so the way we're using this at CCMC is we're applying the idea of functionalization to the model data that we host at the CCMC. We've developed a series of Python scripts called model readers that handles all of the custom data formats, the specialized coordinate grids, and interpolations all behind the scenes, so the user doesn't need to know the right way of reading the files or the right preferred way of interpolating the data. We handle it all behind the scenes with the model readers. By design, the syntax for the model readers is model agnostic, which means the user only needs to know the model name and where that data is stored to be able to interact with that data. For example, the first block of code here is a simple import statement where the user can access a list of the model names. The second block is the user determines where that data is stored on their machine or in the cloud. It doesn't matter. And then uses that information and their chosen model name to bring up an acceptable list of inputs to the reader. And then the third block is how to retrieve this reader without knowing the script name and how to execute that model reader. Notice the only model-specific information is where that data is stored and what name it is. So I can go back and forth between these two notebooks, and the only difference is the name of my variables and those two things I mentioned. You can apply this ad nauseum for as many models as you wish, and that library is growing. For example, I've pulled together a model reader for Wacom Max. And notice that the datasets functionalized are in 4 dimensions. I can make a 1D plot by using the features of Komodo to slice through any time, latitude, and in this case, height, to directly compare and directly interact with the model data. However, this direct comparison only works if those model data are already in the same coordinate system, which is often not the case. For those capabilities, you have to move towards what we call the fly-through. The fly-through function is also model agnostic because it's built upon the network of model readers I just demonstrated. and it automatically handles all of the coordinate conversions behind the scenes. So we depend on SpacePy and AstroPy for the standard systems, and depend upon model developers for any model-specific coordinate system conversions, such as pressure level, which you saw with the WACOM-X, all behind the scenes. Okay, all the user has to do is, again, give the directory, pick some trajectory-specific parameters, and run it. So you see the 2 lines of code in the middle, results underscore CTP and get them, are executed in the identical way for each model, just the different model strings and different directories as before. These output results can easily be functionalized, such as I did on the bottom, and now you have the functionalized outputs for the models. You can very simply add observational data through a variety of methods. One is showed here. This is where we use the Heliophysics REST API to pull observational data from the same satellite whose trajectory was used to fly through the data in the previous slide. That data is then functionalized on this first Komodo underscore object line. And then you can perform function composition here at the bottom to start performing analysis, all without having to care about the different time resolutions in the data. All of these new analysis functions can easily be plotted with a single line of code, such as shown at top. And this screenshot in real life has all of the interactivity the video showed earlier. Command access is possible, and from other languages with more interactive access coming. So these capabilities are significant advances towards the user being able to quite simply perform model data comparisons and even quite easily set up ensemble modeling analysis. Each of the options for trajectory inputs produce the quality visualizations that are being showed in the video here, and that interactivity is preserved by saving it either in a div file or HTML file that you can either embed in your website or play with later. The options are displayed on the left. There's real flight, which retrieves a real satellite trajectory that I've already demonstrated previously, and there's some other options there as well, including 2-line elements, a play trajectory, and providing your own. We've also built, we're also in the process of building tools on top of this fly-through. One particular we call the reconstruction tool. It was built in support of the Geospace Dynamics constellation, and it reconstructs what a given satellite configuration would see in any pair of dimensions. There are a lot of analysis options available, and a lot of knobs to tweak to answer a lot of different science questions. And one of the cool things is that it also has model agnostic syntax, which means it runs the same regardless of what model it is. Another interesting application is that Komodo is being used to include physics-based models for the first time in orbital drag studies. In this case, it's with the Geodyne Orbit Propagator. Contact Katie or Dr. Catherine Garcia-Sage for more information on that. We invite the community to collaborate with us to make your data interactive. It's not as hard as it looks, and it's kind of fun. So the models that you see here are centered in heliophysics because that's where the CCMC specializes, but it can be applied to any data set, whether simulated or observational. Thank you for your time.
Thank you very much, Rebecca. Shell, do you want to come off mute?
No, I just think this is awesome. I hit the hand as I was trying to hit the heart. Sorry. Heart and the hand. It was all going on.
Do you want to have any closing comments on this session?
No, I think we just open it up for questions.
I think because we've run a little bit over here, we're going to go straight to the breakouts. Fortunately enough, many of our breakout sessions are going to be by the people who've given presentations here, so that'll be a good opportunity to ask specific questions and go into detail. And sorry that our technical problems have limited our time for questions. And I don't
But I want to really thank all of our speakers here so far, and all of our speakers today. But I'm going to bring up the slides for the breakout sessions. And so for, I believe, Cindy, are all the online breakout rooms set up? Okay. So the online breakout rooms are open, and so you should be able to start joining them. We'll ask for our in-person participants to join the breakout rooms. So Pangeo Forge will be in breakout room number 1, Komodo in room number 2, Kerchunk in room number 3, interactive notebooks, and I believe Bruce Wilson is also going to be showing off some of the Jedi notebooks. As part of that, will be in room number 4, and I guess then the deep dive into the UDL and K through 12 science education will be in this room and projected remotely. If you know where you want to go ahead and head to the different rooms. So it's rooms 1, 2, 3, 4. So 5. They're in order. So Pangeo Forge is in room number 1. Komodo in room number 2. Kerchunk. Oh, and we're all coming back. Welcome back, everyone. And I think some of you are still sitting in the rooms. We're going to do a 10-minute break. And then at 4 p.m., start the next set of breakouts. And I'm going to hopefully put those up on the screen here. Oh. So hopefully people online see the set of breakouts.
No, we just see everyone's tile.
Oh, nope. Sure. All right.
There it is. We see it. Thank you.
Once again, these will be 1, 4, 5. So we'll have a 10-minute break at 4 p.m. We will come back and go into these breakouts. See you all again at 4 p.m. Thank you very much.
Oh, that's you. Yes. I meant to ask you, are you about to leave here or? I'm coordinating the next one that's in here too. Okay, cool. That's the diverse workforce? Yes. Then I'm in the right place. Yes. So we started talking about stuff. You said that you guys I had done a CSV export of that data for
Hi, everyone. Hopefully you can hear me. We are going to be moving into our breakout rooms now. So if you'll please make your choice and go in that direction, we'd appreciate it.
Let's see. Day 3. Day 3 breakout sessions. Session 2. Topic 4.
All right, I see that we just posted the Jamboard and a Google Doc in the chat, and I see that Ryan just joined us. Ryan Scott, I believe this was your proposed topic, so do you want to start us off?
Give me 1 second. I'm just finishing a bite to eat. I apologize.
Question that was brought up about how do we help make sure that people feel like they belong as being a part of this community?
The Jamboard, so maybe we can just, it seems like with lack of a real leader here, and since you were smushed into this with another
presentation and talk about the science activation program, which is under the SMD partnership.
or an internship or was doing something with early careers, like we evaluate on whether or not like the research is of high quality.
specific Python distributions or distributions with other languages that kind of bring together everything in one place. So there's one installer versus
Jennifer.
Yes, hello. So I just wanted to speak on my experience. So I am a person that
Depends on the different level. So for different levels, for so some tool they are kind of easy for the scientists, but
right? And it's about, this, it's usually a meteorite that's about to come and destroy us all or something of that nature. And they just ask, is this true?
be Afrobeat funk in Nigeria, or it could be cricket in Australia, or it could be Jim Green talking about science. So it sort of spans the gamut.
Of that lady walking and lifting up a fire hose and then walking underneath of it instead of stepping over it. Like, you can't predict, like, what you see in Google does not necessarily
All right, welcome back, everybody. This is Christian reporting from room number 5, now the main room where we all are. What we're going to do next is try to capture all of the conversations in a brief, maybe 1 to 3 minute brief out going down the line, starting with room 1. So room 1, if anyone has a representative that would like to speak, feel free to come off mute. You should all be panelists at this point. Also, let me know if you can hear me.
Everything that I've been hearing, but feel free to everyone to chime in with.
Yeah.
Yep. And for the folks that are in person at the rooms, as you're speaking, feel free to bring up your name.
Oh, we are? Oh.
Thank you. Sorry. We'll report now.
Go ahead, Josh. Me? Oh, I'm.
You have the notes in front of you. Josh is.
Oh, hi, everyone. Are you on the WebEx?
Yep.
Okay, I guess this is Josh Pepper. I'm in room number 1 where we're dealing with the question of that the or a statement or a problem stated that archives need funding for outreach and education. And this was the question that we were talking about, and the issue is that there's a lot of people throughout the country and the world who have scientific questions or practical questions that can be addressed with NASA data, but they don't know the right tools to use or the data sets to use, whereas people who are already part of the system and have already part of the whole scientific and educational establishment already know exactly where to go and who to ask. So we spent a while talking about how to bridge that gap. And of course, most of the discussion centered around funding, because we believe that there is a lot of need for individual people to manage these connections, to answer questions, to show people tools beyond just online tutorials, videos, and FAQs. And that's sort of, and we took a bunch of notes about aspects of that, but that's really where the discussion went around. And this is, of course, really crucial for the TOPS initiative. How do we do open science if we're not actually making NASA tools and data available to everyone? And and it's absolutely crucial that the funding for this or resources for this, in whatever form they take, are stable. In grants for a set number of years are simply insufficient. You set up something, you talk to people, and then you go away and you leave them holding the bag. So any effort to do this needs to be housed in a permanent institutional setting in whatever way that shape that takes in order to make this useful. Otherwise, it's just you're just not addressing the problem. I think that's it.
There we go. All right, great. Thank you, room number 1. Is there anyone online in room number 1 that needs to add any additional comments, or are we okay to move to room number 2? I will count to 10. Okay, fantastic. Oh, wait, we had somebody?
Saying we're good.
Okay, great. Thank you. All right, moving on to room number 2. Feel free to take the floor. I'm seeing fingers pointing in one of the breakout rooms. I'm unsure though.
We're unmuted now.
Oh, thank you.
Okay.
That's too bad because I just gave a brilliantly succinct summary.
She knocked it out of the park.
Oh, well. This is Ann Rao in room 2, and we had a very lively and broad-ranging discussion about barriers to access and reasons why connections are not permanently made between data, between people, between institutions across the United States and around the world, and explored some of the ways that those barriers might be reduced. We talked about things like making assumptions about the tool sets that people are used to using. If you show somebody how to use Python, but they don't ever use Python for anything, that presents a barrier to data access. If you are talking to folks in jargon and it hasn't been translated, that presents a barrier to access. If you require a login before they can get any intelligence about the data or talk to anyone at your institution, that presents a psychological barrier, which is very hard to penetrate in many communities. And so we have many, many notes to sort out in the coming days about various aspects of this problem, but that's probably the most intelligent thing we can say about it at this point. Anybody else want to chime in? I think we're done. Thanks.
All right, fantastic. Thank you, room number 2, and I'm sure that was as beautifully succinct as the first time you did it on mute. Moving on to room number 3. Who do we have in room number 3?
Hi all, this is Lucas. And so our topic was ensuring open source science tools are accessible, and we kind of took accessibility and kind of the 2 prongs of it, one being accessible for people with disabilities, whether that be limited sight or things like that, and also for accessibility just in the general sense of, you know, how do we make it so that someone can go from 0 to using your tool with as little friction as possible. And so we discussed a few things, such as what some groups are using, like in heliophysics. There's HelioPython. There's Project Pythia for geoscience, like earth science stuff, and things like Anaconda that make packaging and distributing your tools all in one place easier and less friction for people to start using them. But also things like creating good documentation and good tutorials that, instead of just throwing out an API reference, actually showing like a minimum, like a small use case that people can springboard off of is really, really important for just for getting people to use your tools. But also another really important point that we went on to was actually the accessibility for supporting things like alt text and stuff. We talked about Jupyter Notebooks, which, while they're good for us to use as if you're an able-bodied, fully sighted person, apparently don't work well with screen readers at all. And so being able to be in compliance if you're writing things for NASA, Section 508 is something I learned about accessibility guidelines and requirements for federally made software, but also just making sure that you involve people who have a range of disabilities in your in your development, so that they can test things out and give you feedback on what works and what doesn't work. Because relying on able-bodied people to do that for you, you can miss out on a lot of stuff.
All right, thanks so much for that brief, Lucas. And is it just you in that room, or is there someone in the back there?
There is someone in the back.
Okay, I'm just making sure you had some company. This seems to be this seems to be virtual inception, because I see you in person virtually and you have virtual people with you there. All right. Moving on to room number 4. Feel free to come off mute.
So we were talking about improving the diversity, particularly in our data centers. Editorial comment: diversity is a necessary but not sufficient step in terms of addressing the things. We had about 20 people. There are multiple aspects of this. We talked a bunch about the role of internships as a means for building a relationship, getting people in the door, the importance of relationships in terms of identifying candidates, getting the word out, getting candidates to believe that they can potentially belong in a place like this. A significant amount of conversation around the question and the challenges in retaining people once they have gotten here. A couple of people were kind enough to share some of their negative and some positive experiences that they had experienced that could be factors. Also, a note about what are the things to get people who may have left for various reasons to entertain coming back. 2 of the people here are boomerangs
as far as NASA is concerned. There is some value, particularly for those of us who are committed to trying to make change, or what's the training that we're missing? What are the ways that we can do our jobs better in terms of attracting and retaining, promoting, sponsoring the people that we're talking about? Folks in the room, folks online, did I miss something important? Thank you.
Thank you everyone in room 4. And then next we have room 5. I'm currently in that room, but is someone virtually reporting out? Ryan.
I might be, I think, based on how the discussion went. So in terms of how to build public trust and confidence in science at large, it was interesting to think about that. We did look at the Pew Research report a little bit more deeply. Someone raised really interestingly that it doesn't really designate confidence in science by agencies, say the CDC effect, masks, and sort of the mistrust that some of the government agencies had in the public, unfortunately, versus whereas science, NASA has a different brand. And so there was our Google Doc and the Jamboard have some interesting content, but in general, how do we concretely build more public confidence in science, more in-person events, and which are respectful and not condescending, which have sincere empathy and not being pigeonholing of any community. And that also these more in-person events are not just for astronauts and top leadership and astronomers, but everyone that's involved in NASA. If you're involved, you know, there's a place in these types of events. Like for example, I know that the Speakers Bureau at Ames, hundreds of events and hundreds of requests go unfulfilled every single month from the community. So that's one way. Having better accessible open access repositories which have multi-language options, those who are hard of hearing, virtually impaired, et cetera, that sort of demonstrate to the public that that NASA's gone to the effort to meet them where they're at and to meet them at their domain. And then having better and strong social media campaigns is also an option. And also in general, this type of campaign is well suited for TOPS to tackle, especially opposed to maybe other agencies. There's not a lot because of that NASA is uniquely suited to do this type of activity due to its history and public brand perception. And also this type of public confidence campaign to really speak to the historical wrongdoings and exploitation of underrepresented minorities and other groups who have been wrongly have troubled history within the United States, so that we all can build a better future together. So interesting discussion, nice open chat. So yeah.
Hopefully you all can hear me. That was a fantastic wrap up for breakout number 5, Ryan. And I really want to show my appreciation to everyone that's been taking part in these breakouts and sharing their thoughts. It's really important that we have these open conversations so that we can start a dialogue to start really improving the way that we do things, especially coming out of COVID with the way we're changing communications. I guess that's a great segue to just kind of bring up that here we are at the close of day 3. We'll be moving on to day 4, talking about some of the way we'll be having a retrospect on the wrap up, on the framing questions. We'll be kind of sending ourselves off with some thoughts on where we can be going moving forward. I know that we're approaching 4:59, so I wanted to leave a minute to either Shell or Steve if they wanted to provide closing thoughts, any closing opinions. Steve? Coming off mute any second.
I just want to say thank you everyone for today. Remind everyone, tomorrow we start at 9 a.m. Eastern, which is a half hour earlier than most days, but we're only here for half a day. So, just as a quick reminder, and I'll hand it over to Shell for the final thoughts.
Thanks, everyone. Thanks for everyone who joined us virtually. Thank you to everyone who is there in person. And thank you most of all for the people who tried to join us in person, but then couldn't and were forced to do virtually. I really appreciate everyone's honesty and bringing their authentic selves to a lot of these discussions. increasing our data accessibility requires these sort of conversations and feedback from people like you. And I'm learning a lot this whole day, and I really appreciate everyone's time and energy and effort. So thanks, and have a great evening or afternoon, depending on where you are.
All right, thanks everyone, and thank you, Shell. And if you are traveling today, please be safe and hope everyone good travels with the storm. Have a good night.